ஹலோ மேம், உங்க வீடியோ வந்து மேல ரொம்ப தெரியுது பாருங்க, அதை கொஞ்சம் டவுன் பண்ணுங்க. இல்ல இன்னும் மேலதான் தெரியுது, இன்னும் கீழே இது பண்ணா. ரைட், ஓகே, now it is all right.
Good morning, Professor.
Yes, Father. Good morning.
Okay. Are you ready?
Yes, Father.
Okay.
We shall start.
Yeah.
Academia Industry Interface is an interactive and collaborative arrangement between academic institutions and business corporations for the achievement of certain mutually inclusive goals and objectives. Academic world is creative, whereas the industry has the task of commercializing ideas. Industry academia collaboration worldwide is quite limited and no model that is widely used exists, though this has always been a topic of discussion on both sides. A productive interface between industry and academia in the present times of knowledge economy is a critical requirement. Industry academia interface brings to meet the industry's needs and expectations and the academic aspirations. In this context, Department of Chemistry, St. Xavier's College, Palenkotai, takes the privilege of organizing today's Industry Academia Interaction Meet 2020 in order to provide a conducive ambience which could facilitate interaction between industry experts and several institutions. We shall start this meet by invoking God's presence. I invite Dr. Andrew Arekaraj, the MSc coordinator of our department, to lead us into prayer session.
Let us all pray. Dear Lord Almighty, you are our shepherd. We praise you in you. We hope in you. Your actions are marvelous in our eyes. You guide us along the right path. We shall never fear about any because you are with us. We believe that your goodness and love is ever upon us. Today we are gathered here to discuss some goodness and for the welfare of the student community. You please bless these speakers and their families. You give your wisdom to such an useful and fruitful teaching learning community. We pray for the good management, teaching and non-teaching faculties and beloved student friends. We trust in you. You guide us and teach us. You show your mercy and love upon us. Praise be to the Lord. Amen.
Thank you, sir. Now I invite Dr. C. Christopher to welcome the gathering.
Am I audible?
Yes.
Now you are audible.
Oh, wait a minute. Good morning, everybody. A warm welcome to the online Industry Academia Interaction Meet. First of all, I would like to welcome our Principal, Reverend Father S. Maridas S.J., who always motivates the young birds to aim high and fly high. Amidst his busy schedule, he comes voluntarily to this portal to encourage us. We welcome you, Father. I also thank and welcome the resource persons representing a variety of fields who have come to share their knowledge and experience with us. Today is presented by three industry experts. First of all, I would like to welcome Dr. Ramakrishnan Vallinayagam, Head Crop Protection Products Discovery, BASF Chemicals India Private Limited, Mumbai. We welcome you, sir. A special welcome to Dr. K. Muthukumar, Scientist, Applied Materials, San Francisco, USA. We heartily welcome you, sir. I proudly welcome Dr. A. Nallasivam, Senior Manager, Pfizer Healthcare India Private Limited, Chennai. We welcome you, sir, to this Industry Academia Interaction Meet. Next in the list to welcome the conveners who are the backbone of this web interaction meet, Dr. Y. Jayavins Ruban, Head Department of Chemistry, and Dr. M. Baby Marietta, we welcome you. The next one, I would like to welcome our senior professors, Dr. V. Jayawal and Dr. M. S. Selvakumar. We welcome you, sirs. I am delighted to welcome all the participants from all regions of our country and world to be present at this interaction meeting. I am very pleased that you accepted our invitation and decided to join with us. In recent days, we have attended so many webinars. Mostly they would be a single way of interaction and might be a bit monotonous, isn't it? But this time it's totally different. Yes, today is your special day. Of course, you are going to interact with the leading industrialists from various fields. Amid their busy schedule, they are very much passionate to answer our questions. So friends, this is the need of the hour to divert our mind from disaster and have a focus towards our bright future. I hope and request your benign cooperation throughout this program for its grand success. Again, I would like to welcome all to this Web Industry Academia Interaction Meet. Thank you.
Now I request our Principal Father, Reverend Dr. Mariadas S.J. to deliver the inaugural address.
Good morning, everybody.
Good morning, Father.
Respected HOD, respected coordinator, respected dean, respected professors, respected resource persons, and all the participants. Good morning to everybody. I am very happy to be with you this morning as we are having this international webinar on industry institution linkage, or let us say relationship, or whatever it may be. The interaction between industry and institution or academia is very important these days. Some time back, there was a survey conducted in Japan. In Japan, in some of the islands, some of the people or most of the people seem to cross the age of 100. So there was a survey taken from all those centenarians, namely, how are you happy? What is the reason for your happiness? And they seem to have cited 5 reasons for their happiness, for their long life. One of the reasons they said social interaction. Industry and the institution should interact these days. Unless and until they interact, it will not be a kind of comprehensive education or holistic education that we are imparting to the students. In our college, we have a STAND program which is linking the institution with the villages. And it is listed in the mission of the college, namely to take the lab to the land and land to the lab. That means we are linking the institution with the villages, and the village is linked with the institution. It is simply because we are able to enrich each other. Similarly, in the academic life, how we are, let us say, interacting with each other is very, very important, so that we are able to show to the society that we are all growing, we are all dynamic, we are all evolving. A human person should evolve. A human person should be dynamic. A human person should be growing every minute, every day. And this growth or dynamism, our life becomes more meaningful only through interaction, only through networking, only through linkages. And I'm very happy that the Department of Chemistry has taken this particular topic for this one international seminar, so that we are able to ensure that we are linked with the entire globe in a much better and effective and efficient way. And this interaction, this linkages, or this networking should help for our profession as well as for our day-to-day life. Therefore, once again, I appreciate the HOD, the coordinator, the convener, the dean, and all the professors for taking this particular topic. I'm also equally very happy to welcome and thank the resource persons for having accepted to enlighten all of us on this particular day. Because today, without interaction, without networking, we cannot lead a good and happy and content life. if a person is going to be highly introvert, if a person is going to highly, let us say, secluded, the life becomes more meaningful. Therefore, I wish that this particular webinar helps all of us for becoming effective in our networking, effective in our linkages, effective in our day-to-day life. Thank you very much for the opportunity. I wish you all the best. May God bless you all.
It's time to straight away enter into technical session by starting with introduction of our today's resource person, Dr. Ramakrishnan Vallinayagam. Dr. Mary Celestine Kala, a senior professor and former vice principal of our college, is eagerly waiting to introduce Dr. Vallinayagam to the audience.
A warm welcome to each one of you for this Industry Academia Interaction Meet 2020, organized by the Department of Chemistry, St. Xavier's College, Palayamkottai. I am happy to introduce the industry expert, Dr. Ramakrishnan Vallinayagam, Head Crop Protection Products Discovery, BASF Chemicals India Private Limited, Mumbai. Dr. Ramakrishnan Vallinayagam is an experienced scientist who has a wide range of experience in various chemical industries. He is the head of Crop Protection Discovery, BASF Chemicals India Private Limited. He is responsible for bringing novel insecticides and novel fungicides in the research pipeline with a team of 40 scientists and chemists. BASF is a German chemical company and is the largest chemical producer in the world, generated resource of 59.3 billion euros and net income of 8.4 billion euros in 2019. It is operated under 6 business segments like chemicals, materials, industrial solutions, surface technologies, nutrition and care, and agricultural solutions. In the year 2017, Sir was working as a group leader responsible for bringing novel insecticides in the research pipeline with a team of 20 scientists and chemists. He also worked as a senior research scientist for novel insecticides, kits and leads project with a team of 5 chemists. He was also the principal investigator, Crop Protection Products Discovery, DuPont India Private Limited, DuPont Knowledge Center, Hyderabad. The title of his thesis is Synthesis of Novel Prodrugs for Targeted Phytodynamic Therapy. Out of his research experience, Sir has published large number of research papers and also received a number of awards. Really, we are blessed with such an eminent scientist. Now, I invite Dr. Ramakrishnan Vallinayagam to start this Industry Academia Interaction Meet 2020. Welcome, sir.
Thank you. Thank you very much. I hope I am audible.
Yes, sir.
Yes, sir.
Okay, let me share my slides. Okay. Are you able to see my slides?
Yes,
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 sir.
sir.
It is
Yes, sir, you can go ahead.
Just a minute. Okay. First of all, thanks to everyone. Good morning to all for joining this session. Thanks to the principal, thanks to Dr. Baby Marietra for inviting me for this talk. It's my delight to connect with the students and also the faculty members. And thanks, Professor Kala, for the kind introduction you gave for me. And today I would like to start with four disclaimers, I would say. Sort of number one is like I will give a talk in English, of course, but certain times, if I need to stress some things, I may switch over to Tamil, and I hope most of the people could understand Tamil. Second disclaimer is since we are talking about the research about the industry, I may not talk about many confidential chemical molecules which is in the research pipeline. So I try to give an overall view about how the industry functions and what does BSF do and how does the students can learn from industry and all. And third one is all about safety. So since I mean it's our culture in our company, not only in BSF but also at DuPont where I worked before, um, it's our culture to start any meeting with safety. So safety is considered as the prime important, and not only for our life, but also being in chemistry and chemistry labs, safety is considered as the prime important day of, prime important in every day of our life. So in any meetings, we start with safety anecdotes or safety message to share. So today I would like to share about safety message, which is very simple, which we all know is all about Corona. So I request all of you to take seriously the hygienic measures, hand wash, mask, and everything to not only keep yourself safe, but also keep everyone safe around you, and so that our country as a whole can come out of this pandemic with much less mortality and we are back to normal soon. So with that, I would like to shift to the topic today. So with the next slide, I would like to show is about, this is the picture of our BSF research campus. This is in Navi Mumbai. What we call them is an innovation campus. So this site in Navi Mumbai is not only the research center, we also have a production site behind, and we also have business groups working side by side. So this is sort of one unit where we could interact with production people, business guys who are from marketing and sales, as well as other people in the support function. And as you could see here, this is the Turbe railway station. This is the railway station, the New Bombay line. It's just located opposite to this Turbe railway station. So this building, our innovation campus, is 6th-floor building. And I'll tell you more about this campus infrastructure and others in my coming slides. So before we start about the discussion, I thought of mentioning I'm typically born and brought up in Palankotai. So I am one among you. So I was born and raised up in NGO colony. Many of you might have heard about this place in Palankotai. So I had studied my primary school in St. Joseph School in NGO colony, and later moved to St. John's Higher Secondary School in Palankotai. So as many of you know that this is a sort of a rival school to St. Xavier School. So the anecdote here is mainly about, even though I have not studied in St. Xavier School or college, I was always lived around St. Xavier School and St. Xavier's College. I had many friends in school times from St. Xavier's as well as in college also. So when I studied in St. John's School, the main reason I went there is for English medium. At that time, St. Xavier School was not having English medium, so that's why I went to St. John's High Secondary School. And not only in academic, both St. John's and St. Xavier's, even in sports at those times, we used to have tough competition at that time, especially in hockey. So many of the faculty members or older colleagues we know, as you could see, the years are pretty long time before. Many of you might not have born during this time. So I'm old, okay? So please listen to me carefully. So with this introduction, so what made me to look into chemistry? So during my school days in 12th standard, I'll tell you very specifically, is not because of my school teacher, to tell you honestly. I had my tuitions chemistry teacher. His name was Chandra Shekhar. He was a school teacher in St. Xavier School. So with him, when I was doing chemistry tuitions, I got interested in chemistry. The way he connected formic acid, formica means red ant, formic acid means that's what red ant has and all. And even whenever we get a good marks in our tuition exams, he used to present a chemistry in everyday books and all as a gift. So when I try to read all those things, chemistry in everyday life, how toothpaste has got triclosan, an antibacterial, all these things. When I read this everyday chemistry applications from that book in my 12th standard, I got more passionate about chemistry. That's how I made thought of choosing chemistry. But to tell you honestly, after my 12th standard, I always had plan A, plan B, two plans always in my life. And most of the time, plan B only worked, to tell you honestly again. So at that time, after my 12th standard, of course, my plan A was to have a chemical engineering or Government College of Engineering in Tirunelveli and all. Unfortunately, with my marks, I was waiting for counseling and all. Unfortunately, I could not get selected. So my plan B was to go to chemistry directly, no BSc physics or maths. I wanted to do only chemistry because I loved chemistry at that time. And the point here is, since I was waiting for counseling and all, it took some time. And by the time I wanted to come back to plan B, St. Xavier's College, St. John's College, everything was full with admissions. So the only college I had was Sadakatulapa College. Many of you might have heard about this college also. And I was very fortunate, even though many of you might have think about this college is may not be so popular at all in Tirunelveli and all. The reason I chose was it was available. And at the same time, I had my seniors studying in that college who told me a lot about the faculty members who are excellent in this college. So I always have this second habit. I'll tell you, besides plan A, plan B in my life, I always have a habit of connecting with my seniors and juniors all the time. Seniors to get advice and juniors to guide them sometimes. This is my habit also. So when I talk to my seniors, they always said like, this college, even though it's not so popular, at the same time, the chemistry faculty at that time, Professor Y. Syed Mohammed, Professor Kamal, and all very excellent professors who try to help students. So that made me really happy to join this college. And to give you some more anecdotes, they gave me complete freedom to do whatever I want. So even during Friday times, during mask times, we had 2 hours, 3 hours in Fridays. So I used to go to talk to the professors and ask questions and understand more. I was more curious, and one day I had my friend's contacts working in Liquid Propulsion Center in Mahendragiri. So during my third year of BSc Chemistry, I asked my Professor Y. Syed Mohammed, I would like to introduce this scientist at Mahendragiri for a talk. What do you think? Huh? And he said, go ahead, don't worry about it. We'll support whatever you want. Unfortunately, it didn't happen. The scientist was so reluctant to come to college and give me, and he must have thought, what is this BSc guy asking me to come and all? Probably it didn't happen. So still, I didn't leave my hope. Then I went to another person from SPIC at Thuthukudi to invite such. This person also didn't come. Again, I went to a college professor at that time, Government of College of Engineering. So my neighbor was he was a professor in that college. He came from IIT Kharagpur after many years. So he was very also passionate about chemistry. He's a very old person. So, but I told him, I would like to have you in our college to give some talk about IIT Kharagpur and all. He said, why not? I will ready to come and talk. So my professors encouraged me. I made this sort of talk every quarter, once in 3 months, to invite such people and do it. And my professors give me total freedom, whatever I want to do. And I did like this, and people enjoyed it. And I also enjoyed such interactions. So for those who are listening from BSc students or MSc, please go ahead. The life is and college like St. Xavier's College gives such all facilities and freedom for you. Go ahead. If you have curiosity in your life, go ahead and invite people you know. This will be good for all of you. Huh? Now, the question here is all about perseverance, how to do this. At the same time, make yourself interesting and don't think about others. You know, there are people who may laugh at you. Even I had my classmates who were telling, what are you doing? Why are you inviting? You don't have any other job or not. I didn't care about it because I wanted to have my knowledge thirst and knowledge curiosity, just to have interactions from others and learn from them. So this helped me a lot. So going forward, what I decided was my journey, why I put up all this in red font, I'll tell you at the end of these 3 slides. I went from here to Maharashtra, a course called BSc Tech Chemical Technology here. So this is course in, previously it was called UDCT, University of Mumbai, Department of Chemical Technology, UDCT. So here again, how did I land up here? I was initially studying MSc chemistry at American College, Madurai for two months or 3 months. So at that time, I got this offer from this BSc Tech. This at that time was after BSc chemistry 3 years, but now it's been changed to 4 years after 12th. So I chose this because again, I had my friend who was studying at St. Xavier's College, again a senior, and he did this BTech here and he was working for Asian Paints at that time. So he used to tell me, well, Inagam, this is a good course where if you want to have a job immediately after your studies. Then I thought after, while doing an MSc for 2 months in American College, I thought I would rather go there because I need a job to start after my studies. So with MSc, I thought I may need to do PhD and maybe it's pretty long for my career. I didn't want to depend on my brother's support for finance. So I thought I'll go for this course because this may give me a job like my senior friend from St. Xavier's College told me. That's how I landed in this course. I pretty much enjoyed this course because this chemical technology and chemical engineering course is number 2 after IIT Bombay in chemical engineering and chemical technology. So I had a pretty good exposure to interact with not only my classmates from various regions, from Assam to Jammu and Kashmir to even people from Ambasamutram College, as well as Kerala, but also professors. So it gave me a good exposure. Fortunately, one of the very good thing my brother did was I learned some Hindi in my school days separately in Dakshin Hindi Prachar Sabha. So that made me a little bit okay for me to swim in this Mumbai Hindi parlance, I would say. So this is what my journey continued in Mumbai. And during the studies here, at the end of the thing, we had our campus interviews. So again here, I went for different campus interviews. So I was almost selected for a company called Glaxo in pharmaceutical company. That was my plan A again. And my plan B was this Garda Chemicals. This was an agrochemical company at that time, 250 crore Indian company, started by Dr. Garda, Keki Garda, an Indian, but now it's around 1,000 crores company. But my plan A didn't work. Glaxo didn't select me at the last interview. Then I went to this chemical company, agrochemical at Ratnagiri district, which is an interior part in Maharashtra, Lote from where they speak the pure Marathi and all that. Then after 3 years living in that jungle, I would say, I thought this is enough for me. I would like to move on. So then I thought of going to near to Mumbai. So this place called Kopoli is near to Mumbai, just 1 hour drive. So this is a company I got an offer from a chance, a company called IOCL, Indian Organic Chemicals. They are making a lot of basic chemicals like acetic acid, ethyl acetate, and they wanted to venture into contract manufacturing at that time. So I thought I'll give it a shot. Again, the reason being my plan here at that time was to go for MBA management. I always appear for CAT exams and Symbiosis, SP Jain, Delhi School of Public School and all. So I was curious to go for MBA all the time. That was my plan A always. I thought I had many friends in Mumbai and also I could interact with them. They were doing MBA, so I thought I'll also do MBA. I never know basically what is my strength, what is my skill and all. I still appeared for many MBAs. Again, as I always told you, my plan A didn't work out. Then I continued for plan B. So I thought of, I wrote TOEFL exam. I cleared it in a good score. Then I also wrote a GREs and all. So fortunately, during this time working as a bench chemist in the lab, I got curious about many reactions. In some other presentation, I can explain about a little bit chemistry about that. I made some mistake of adding some starting material wrongly in Friedel-Crafts reaction. It went really bad. The reaction becomes really hard rock-like mass. So I had a contract manufacturing supervisor who came from Ciba-Geigy in Switzerland. So they also gave me a training 2 weeks in Switzerland at that time. So this Swiss German supervisor told me this is a wrong reaction, please throw it away and start another reactions. Each reaction takes 12 hours to do workup and all, it takes another 6 hours. So at a stretch, I worked for 18 hours a day. And I did this, I didn't throw away that reaction, but I started a new reaction and I was curious as I always, I am always curious to know what is happening in that wrong reaction, which became rock-like mass. And I tinker around that reaction. I found pretty good, fantastic compound of quality and good yield. And my supervisor was really excited to see that. And he asked me, I asked you to throw it out, but still you persisted and do it. Why did you do it? And I said, I was just curious. Then he told me, why do you want to do MBA? Why didn't you go for research? You are a curious guy. You had intuition to do chemistry. Why didn't you do PhD? And I said, yes, that's why I'm trying in TOEFL and GRE. But he said, no, why don't you go to Switzerland with my professor? I can give you recommendations. So that's how I landed in this university, the Neuchâtel, at Neuchâtel in Switzerland. This is a French-speaking area. So I had a wonderful, not only a mentor in my company in Sibagagi, who mentored me, who told me what is my strength and skill, rather than I was not sure what is my strength and skill. And he was able to guide me. And then I landed in another fantastic professor, Professor Reinhard Neyer. He also tried to guide people how to go for industrial career or academic career as a professor and all. He was excellent not only in chemistry, but also tried to guide people how to present by putting a video camera in our group, in our PhD, and try to really uh, really make us prepared for industry job or academic job. Same thing with my postdoc professor, I'll tell you later. So this, with him, I really enjoyed. I had a good collaboration with an hospital, CHUV Hospital at Lausanne. So I did some chemistry, which is not a great chemistry, but still I love that chemistry. It's a photodynamic therapy for cancer. So again, as curiosity, as I say, during the end of my PhD, I thought of coming back to India because I was pretty old, because I started PhD very, very late after working for 6.5 years. But as luck would have had it, or as you say, God's grace, in one of my end of my PhD, there was my professor's friend who came from Yale University. He was nothing but Dr. Andrew Hamilton. He was talking a lot about his subject. Then, not out of getting impression or try to show off myself, I asked some doubts about these protein-protein interactions. I said, why, Professor Hamilton, why do you do in one side of this aromatic fullermers? Why don't you do in another side? You can have amphiphilic side and all. Then he said, hey, Wally, what are you doing? Why don't you come for a postdoc with me to Yale? I said, why not? That's a good thing for me in my career. So that's how I landed at Yale University to do a postdoc again in medicinal chemistry, which is about alpha helix mimetics biochemistry for disrupting protein-protein interactions. So during this time, 2009, again, I don't want to tell anything sugar-coated. I was trying for a job in US at that time. During the time of early depression time, I didn't get any chance in Pfizer or Pfizer Connecticut or BMS and all. So then my plan B was to come back to India. So at that time, I went to a American Chemical Society conference. So it was a very, very big American company called DuPont. They told, we are starting a research center in Hyderabad. Would you like to go? Then I said, that's a great idea. So I could go back. It's still in South India. So that's how I landed up in DuPont India crop protection, because I had an experience in agrochemical as a process chemist in Garda Chemicals, but this is more about discovery. So I thought I'll go there and experience myself. So after almost 3.5 years, I got a very good chance in BSF Chemicals in 2013 as a senior scientist. That's how I landed up here and came to BSF. So a little bit taking long time. I wanted to show this red um, font is because more you are flexible, adaptable to different regions, more you will get more exposure and knowledge. So this requires many things, adaptability and language. So not only I learned French very well in my PhD times, I could speak fluent French. Even now, I communicate with my friends in France in French, and I also speak Telugu. And during my Tirunelveli time, because my father is from Kerala, I speak Malayalam also. So now I learned Marathi also very well. So as long as you speak good languages, as well as you are adaptable, then you have to go out and experience different exposures and learning. This is simply, I would say. So my today agenda, I'll go quickly, is about BSF and chemistry and what are the suggestions about students in chemistry. So in BSF, I'll slightly touch about one or two slides. How is our global business? Professor Kala already mentioned about our business segments and our turnover. And global research, how do we operate? I'll mention about that. And I'll also talk about research in India, why BSF come to that, and how chemistry could solve the global problems. I'll mention about that a little bit, and also about sustainability, because these two are very important for chemistry to survive for another century or more than a century and all. And finally, about BSF focus in India. So these two specific points was Dr. Baby Marietta was mentioning me, what should the students focus on if they aspire to work for industries, and if there is any suggestions from my side in organic chemistry for curriculum to adapt to industry. So these are all my humble suggestions. It may work, it may not work, but I'll just share in one slides at the end of my talk. So BSF and chemistry about global business. So what we talk about here is we work on these strategic principles and values. So we always have these principles: why, what, and how, which means we really would like to contribute to the world which provides a viable future with an enhanced quality for life for everyone. So how do we want to do that? Our principles lays on, we are an integrated global one company. So even though we have different business segments, different research functions, we try to think as in one company to add value to our customers. So as many people say, customer is the king, customer is the god. We try to innovate to make our customers more successful. So BSF, as you could say, it's always a B2B company, so business to business. So we are not directly much involved directly with the customers. That's also one reason you might not have seen many social media advertisements or publicity about BSF, because we always supply to the business community. We directly interact with customers in very few segments. And one of the things as a chemical company is we always say, not only we want to innovate our customers and make them successful and happy, but we also try to drive sustainable solutions, keeping in the environment what we are working about. So that we have to work for not only for today's environment or the next generations, what will be sustainable. This is our principle embedded in our culture. And we found the best team. So having all strategies and principles is great, but ultimately it's all the people who drive and make it happen. So you want to have the best team always to drive this very openly and honestly and creatively to ensure that. That's what I mentioned it in this last one. Open in the sense we value diversity. We not only diversity in race, religion, and people, but also in opinions and experiences. This is how we foster different diversity based on just honesty and transparency and mutual trust. And more about responsible. So this is not only we are responsible for our employees and their families, but also the society which we live, not only the community which we are operating, but also as the whole country. We have to be compliant as per the country where we operate. At the same time, we are responsible for the whole society what we are working for. And entrepreneurial, yesterday also I was listening to your academic interactions. It's pretty interesting. I liked it. One of the participants also mentioned about entrepreneurial research. So this is also very useful. We always try to think how the employees as an individual, as a team, can think about the customer needs and try to have solutions according to that. So with this, I go to give some little bit details what Professor Kala also mentioned in the introduction. So this is our chemistry is used in almost all industry, in automotive industries and paint industries, and also agricultural solutions. I'll touch upon in the next slide about that. So as I mentioned, we have to make money to economic success is important, but at the same time, it's very important to do with social responsibility and environmental protection. This is our principle, and this is our sales. As many things may not be known in these figures, this is not a very good year. This was not a very good year for BSF as a whole, due to many challenges between US-China trade war and all. This was not a good year. 2018, from 2018, we are down in the sales. Even our EBIT means earnings before interest and tax. That means nothing but profit. This also got down due to many issues. So we hope probably next year it may come back, because 2020 is also not a good year, as many of us know about the COVID pandemic is also giving many such issues for all the companies. So employees all over the world, we have around 120,000 people. We have something called in German, Verbund. This V is called F, as they pronounce. So we have 6 Verbund sites and 361 production sites. What does this mean by Verbund sites? I'll briefly touch upon this. Verbund in German connotations is all about interconnected. So we have this Verbund sites in Germany, in Ludwigshafen, which is near Frankfurt. So what does this mean by? This is a system which creates efficient value that extend from basic chemicals to the customer products, which means all our chemical production process make use of energy more efficiently and conserve resources. What does that mean? Byproducts of one production plant and one process is used as starting material for another process. By this, we save raw materials, we save energy, we minimize emissions, we cut logistic costs, and we realize energy synergies. So this is how we operate our one of the largest chemical complex, which is in Ludwigshafen in Germany. And we not only that, we have many Verbund sites across Europe, Asia, and North America. I'll touch upon in my last slide. This is a concept, unique concept, which we are proud of it, which gives unique advantage for our business and production. Going forward to the next business segment, as Professor Kala mentioned, this we have operating in six segments. Chemicals, this is about petrochemicals and intermediates. So this segment is supplying majority of these basic chemicals either to our own different business segments or outside of BASF. So this is mainly giving our components to chemical industries and plastic industries. I'll touch upon that later. And to be highly competitive here, besides chemistry, more important here is chemical engineering and technology to produce in a competitive cost. And the material segment, it consists of performance materials and monomeric divisions. Here, this consists of many precursors for materials. So this includes many different polymers, polyamide, polyurethanes, and many other polymers which cater to the automotive industries and also other industries. So here again, we focus on organic growth as well as satisfying the customers from automotive industries. So the third one is industrial solutions. Here, this is about dispersion pigments and performance chemicals. So here we cater to fuel and lubricant solutions and dispersions and pigments to paint industries. And we also supply electronic materials to Samsung and LG for many of the mobile devices and LED and LCD one. And the next one is surface technology. Here we talk about mainly a catalyst and coatings divisions. So this catalyst, we have a production plant at Chennai, which we make as a catalytic converter. So every car which you buy now comes under Bharat 6 emission norms, which is equivalent to Euro 6 norms. So these norms has to be satisfied to absorb SOx, NOx emissions if you have the right proper catalyst converter to absorb these gases, which is emitting from a car or bike. And all these converters are made by BASF, and we supply to Hyundai, Honda, Suzuki, Maruti, many of these companies. So that's why we have at Chennai this production plant. And we also have battery materials in this one. So we are doing a big venture in battery materials in China and Europe for many of the battery vehicles which is started. And nutrition and care, I'll touch upon this later also. So this is a company, this is a segment where we have a sophisticated demands for fast moving consumer companies. For example, we are one of the largest producer of vitamin A and vitamin B2. So these are some of the nutritions which caters to the pharma companies, nutrition companies, personal care companies. And also, we also take care of some of the requirement from personal care and home care companies like Hindustan Liver and all, where we supply enzymes and ingredients for the detergents and other applications. And last but not least, agricultural solutions. This is where I belong. So this is divisions where we try to give a provider of solutions to the farmers, right from customized product in chemicals, seeds, and genetic modified seeds, and also about digital. Not only that, we also provide biological products, even organic biological products like pheromones, also depending on the need of the customer as well as depending on the market and all. So we provide these in the customer solution for the farmers. And going forward, I talk about global research in BASF. What do we do here? So basically, R&D is a foundation for our present, past, and future innovation. So I briefly go through a history of our innovations. It's pretty long, but I'll try to catch up with a few important innovations. So we started as a synthetic dye company, moved to fertilizers, plastics, healthcare, nutrition, and crop protections. And we are in future going in systems, which means systems as a digital as well as chemical together as a solution for the whole people. So this is how we completed more than 150 years. And this was all about our key innovations which made us sustainable for more than 150 years. So I'll talk about only the few important bullets here highlighted. Indigo, as some of you know about, it's a indigo, it's a dye which was extracted from indigo plants, indigofera, and it is being utilized for many of our genes which we use. This blue color comes from indigo. For our genes, it takes 3 grams of indigo to apply. So at that time, whole time, it was the first time BASF invented synthetically to make indigo and supply textile industry. So it is just a indole diet or indole compounds connected by a double bond. And at that time, it was a big innovations catering because we don't need to sacrifice many plants to make such a dye out of it. And another important innovations I will also capture in next slides is about ammonia. Yesterday, also in the academic interaction, Dr. Kannan Raman mentioned about how ammonia production solved many of the food production in the whole world. I'll touch about that later. And magnetic tapes, many of you may not know that many of the old tapes, audio and video tapes, where BSF was manufacturing. This is because in the dye stuff industry, we had the capability to manufacture extremely fine divided iron pentacarbonyl, and that's how it was used in the magnetic tape for the coatings. So at that time, we were manufacturing these for some digital companies, or not digital, I would say electronic companies at that time. But we quit all these companies after we found it becomes a commodity, and we try to go to next innovative products. That's how we went here. Vitamin A, as I mentioned, we are number 2 producers, around 3,000 tons per annum. We have different production plants in Malaysia as well as in Germany. And vitamin 2, we try to make it from an organism called Ashbia gossypii. This is also in a biofermentation process, which we are also doing in a very big scale in Germany. And strobilurin fungicide. So this is a fungicide invented from a natural product. We had an academia collaboration with an institute called IBWF in a place called Kaiserslautern in Germany. So these people, together with BASF, invented this natural organism called Strobiluris telatanus. It's an organism which has got this fungus has got this natural product which can inhibit other fungus to grow. So we try to make use of this natural product, but it was highly photo unstable. So we try to make many modifications, and we finally launched this product. This is also one of the big fungicide product in the whole industry, not only in BASF, across all crop protection industry, even still valuable even nowadays. Last but not least, I wanted to focus the recent innovations called Ecovia. This is a polymer which is a completely biodegradable and compostable polymer. This we are selling in different for the garbage bags as well as many plants. Recently, we launched it in Pune municipal corporations. So this is made from a completely biodegradable EcoFlex polymer, and also along with polylactic acid. This is made from completely renewable sources based on sugars. So that's how we try to focus more and more in this direction for sustainable solutions. And going forward, how our global research is helping. So this is one of our biggest investment in our whole industry. So we are very proud to say about consistently high expenses in R&D. So in the last year, we spent around 2.16 billion of euros. So you see here in different segments, we split up. As I mentioned, some of the segments have a less percentage because they are more focused on technology and productions, whereas agriculture solutions, which I work, is focused more on more research, because I'll tell you later also about slide, why do we spend more? Because of more expenses happening. And these are our expenditures, and sales of around 10 billion out of our 60 billion comes from new innovations. And even nowadays, we are coming around 20 billion is coming from new innovations. Why this is important? I'll briefly touch about sustainability. What is meant by sustainability? So we always classify our products into 4 different categories, which means accelerator, performer, transitioner, challenger. What does this mean by accelerator? Means not only our products are compliance according to the country regulatory, but it goes beyond that, even satisfy for next 20 years and all, which means it's really highly safe, we know from our own experience as well as our research. So almost 25% of our product is coming from accelerator. So we want to push a lot of our products from our performer transitioner to accelerator. Next comes performer, which means we know these products not only compliance the standards of the company, country, but also it's satisfied for the whole customer base. Everyone loves to use that. And transitional, which means this is a product which comply again to the company, country standards, company standards, and the customers. But in a span of 10 years, it may need some changes. Otherwise, we may need to go out of this. And we also know that by putting a lot of research, we can transform this transitional products to accelerator or performer. We know that. Last but not least is challenger. We hear is a challenger means we still complies the country standards, regulatory, but at the same time, in a short span of 5 years, it may not be able to compliance the standards which the regulatory boards needs. So this we always try to quit from this business so that we try to have highly compliant, sustainable product for the future as well as the present. That's all we put all our money into this with 11,000 people working in that. And we are also very proud to put a lot of our research, and that's why we are proud to say also about our patent asset index, which contributes, which try to collect how much new patents are made from different companies. We are proud to say that more than 1,000 new patents were filed in from BASF in 2019. More about a little bit research, global research. We operate in all three regions. Process research and chemical engineering is more in Europe. In Asia, it's more about advanced materials and system research. We started around 10 years before in Shanghai, 2 campuses. In India, 2014 we started. 2017 we had a new campus. In America, we work more on bioscience research. So that's how even now, presently, our major focus of research in Europe, less on America and Asia. What we want to try to achieve in the coming years is to have equal distributions in America and Asia and less in Europe. So by this, all our growth in research, we want to expand. We would like to expand only in Asia and America so that we don't depend only on Europe all the time in our research. This is for 2 reasons. One is all about the people where there is a growing. The countries like China and India is growing. So that's where the business is happening. So we want to have our presence, and we also have a lot of talents here. I'll also touch about that in the next slide. So this is BASF research in India. So why does BASF want to conduct research in India? So many of you wonder, besides China, why do we come here? One of the reasons is talent. As you know, this is a very small graph, but still I would like to tell you. If you see in the STEM talent pool, science, technology, engineering, and mathematics, second talent pool lies in India after China, the whole globe. 2.8 million graduates are coming every year nowadays, more than 2.6 in 2016. So there's a talent pool lying here, unlike Southern America or some other countries. And market, we are one of the largest growing country, 5th largest GDP, fastest growing major economy, and also 3rd largest chemical industry in Asia. So this also makes us attractive for BASF to have a presence in India in research. Technology, we know that world-class academic institutions are there, IIT, IIC, and NCL. I'll also mention in the next slide, how do we operate? And also we know that very big industrial research centers were there from generic pharmaceutical companies like Reddy's, Cipla, and all. So this also made BASF too attractive to come to India. Last but not least, our populations and higher number of middle class. This makes it attractive, young populations. We can not only cater to the market, but also benefit out of it. So this is about our campus. So we have our synthesis group, process development group. We also have computational molecular modeling group, data science group, and analytics. We also have development group, which works for the business group, which is called application labs. We have a creation center to work with our polymer clients. And we also have a big patent group to work, to file our patents, whatever we invent here. And even though we started in 2014 working, but this campus was built in and inaugurated in 2017. We could accommodate around 300 employees, but as of now, we have only 170 employees. We are 70% occupied. We will be still going more in the coming years. We have this certificate, which is called Leadership in energy efficiency design. This is made from a US Business Green Council. That's why we got this award for this building. And in this 6 business segment, we operate majorly in agricultural solution, which is my group. We also operate a research group and application lab, which is called development labs in nutrition care, and also have industrial solutions, research and development, another groups working here. So going forward, how do we interact with academic people basically? So when we started 10 years before in China, in Shanghai, we have 2 campuses now. We had many of these universities collaborating with us in different fields from top universities and institutes in China. And when we started in India, in the last 2-3 years, we started expanding our network with all these institutes. As many of you are already collaborating with these institutes, we chose them due to different subjects which we work with them, as well as proximity to our centers. In National Chemical Laboratory Pune, ICT Mumbai, where I did my undergraduate, and the IIT Bombay, as well as Bangalore IISc. So this is sort of what we call as network of Asian open research. With that, we try to interact with our academic colleagues for our projects, our future needs and all. Because we strongly believe everything cannot be made by us. We need to depend on other collaborations in academic as well as companies. So besides building, it's more important about the people. So if you are in young organizations, besides the building, it's all about our people. Almost 30 people are with PhD and postdocs. We have around 100 people in MSc chemistry, organic chemistry mainly. And many of our PhD and postdoc people have international experience in their PhD and postdoc. And we also have in-house PhD program for our MSc chemistry people. So a few of them have joined this program and doing PhD in IIT Bombay, ICT Mumbai, and NCL Pune. And we also have career synergies with PSF India, the business colleagues, marketing and sales. So wherever we find a need, we also try to exchange people there. And we also have delegations for 1 year, 2 years, 3 years, exchange between our colleagues in Germany and China with India. We also have short-term visits to our bench chemists as well as our scientists as well as leaders to have such visits and understand more. So with all these things, we have very low attrition rate, and we would like to say we are an attractive employer in this region. So here are a few pictures about our campus. This is our canteen, this is our cafeteria, this is our entrance, this is a small analytical lab. This is atrium, which means here is what people sit and listen to a big town hall meetings where people can sit for 300 people and sit and listen to our chairman talk or something like that. Here we have a terrace. We used to have some lunch or dinner whenever we have visitors. And these are all our labs, these analytical labs. We have many, as you could see, many HPLC, LCMS, GCMS, and 2 NMRs. One is 600 megahertz and another is 400 megahertz NMRs we have. And here is a fuel and lubricant solutions lab. This is a application solution lab from development research people. And this is research synthesis, which performance chemicals and agricultural solutions, which is in 2nd floor. And we also have a pharma solution lab. Again, this is for the application directly to the customers, which they operate in 3rd floor. And we have a kilolab in 6th floor, where we operate for big scales to make in 5 to 10 kgs. Whenever we make compounds and we want to go in a big scale in field trials, where we need big quantities, we try to make in this kilolab, or we call it as mini plant, to make this in big quantities and then generate for our field trials in agricultural fields. Going next is how chemistry solves global problems. It's very simple. We always believe chemistry as a key enabler to meet the current and future needs, not only in agriculture, health, energy resources, construction and housing, consumer goods, transportation, and electrical electronics. So I briefly touched about transportation, which is automotive industry. We are supplying a lot of lightweight materials made out of thermosetting polyurethanes, and also about catalytic converters. And electrical electronics, we had a OLED business which was serving Samsung and LG. And in consumer goods, we supply UV antioxidants for some of the sun creams and all. Also about personal care, we supply Hindustan Lever and all. And construction also, we have a business where we have master batches to supply many of the ingredients for the cement and others to make it very strong and easily adaptable. Besides this construction chemicals, we also serve energy and resources. We supply some catalytic converters even for coal industries, and some of these materials made for the wind turbines also we supply them. I also touched upon these two already. So here is a one little bit not sort of a questions, but I'll give you answer. This is more about how this the population has increased over a period of centuries. So as you could see here, this population here was in million at those time. It became 1 billion, and then it became within, it took 100 years to become 2 billion, but to become another 1 billion, it was quite fast in 30 years. And to become double 3 billion to 6 billion, it happened within 30 years. So with all this huge increase in population, why the population increased and how this is was able to sustain. So yesterday, the academic resource person, Dr. Kanan Ramayan, also touched upon this. It's not only BSF which believes, but also many of the scientists across the globe believes this is mainly due to the innovations made by BSF and academic institute professor, which is called ammonia. As many of you might have studied in your BSc or MSc about Haber-Bosch process to make ammonia from nitrogen and hydrogen. This was invented in, at that time, 1907 or 1913. He's a Carl Bosch from BSF. He was a group leader scientist at that time. He is Professor Haber, Fritz Haber. He's from University of Karlsruhe. So he invented this process with the help of catalysts called osmium and uranium and all. Then he collaborated with Carl Bosch in BSF, and they collaborated and tried to see how this can be made use of to make production in big scales. This is one of the big catalytic pipe which they made. This is still there in our campus. People make a tourist visit to this one. So where he converted from osmium and uranium, which is a very difficult catalyst to source as well as make. So he made it into an iron-based catalyst, which made it possible, cheaper, and people are able to make ammonia from that, able to make nitric acid, nitrate, which becomes a huge need for fertilizer in crop production. Why do we need that at that time? Due to the huge increase in population, we need food, we need fertilizers. Because at that time, people depend on nitrates only from one country region called, in a country called Chile, the sodium nitrite was available. So they were able to extract a lot of these fertilizers and supply the whole world. So they depend on only that natural resource. So after this happens, the fertilizer production went in a big way and people are able to make more food and population are able to sustain. But it comes also with a problem. The fertilizer becomes highly become pollutant. It got contaminated the many water bodies across ocean and all. So which also needs sustainability, which people are making course corrections and making come back to a better sustainable solutions. So the last one I'm trying to touch upon is my field. So this is from flask to field. What is discovery and development in crop protection products? So ultimately, what we think is we want all our customers, farmers, to see their smile in their face due to productivity. So this you could see the corn, and in Tamil Nadu, the farmers is happy with the height of the corn and all. So why we are putting this? We want to see the smile in the farmers, and with the new technology, not only digital, which we also supply, even on precision application where we want to apply, but also with the extremely sustainable and environment friendly products. How can we do that so that not only the farmers are happy, but all the end users, consumers are also happy to use these products so that we can make our planet happier, at the same time have more productivity. Why do we need more productivity? Again, as I stress upon the world population and arable land, as you could say, it's entirely in the different directions. Whether we like it or not, the population is going high and we have to feed these people, whereas the land is going down because people are migrating and occupying different irrigated lands also. So how to do more productions to feed these people with the less land? So here comes the solutions, sustainable solutions. So this is all about the United Nations 2018 Global Agricultural Productivity Index. So this is about how If you see this global agriculture productivity, what they term is as total factor productivity, which means this is not about simply output. It's not equal to output. This is not about yield. This is output per unit of land, not about just yield, but also it's a ratio which takes into account of how efficiently not only land, labor, fertilizers, feed and machineries are taken care to get the output. So if you see this, this is the requirement for 2050, and this is what the projected growth in many countries, and this is a projected growth from low income countries. So there's a big gap. We need to catch up to feed the people efficiently, at the same time effectively making use of the resource available. So we also are proud to show this slide always. This happened in 2010. This is not Photoshop. It was made in one shot. We try to have corn as an example, how the corn crops can have different effects without these ingredients with the help of chemistry innovations. With herbicide, with no herbicide, with insecticides, how the growth of the corn is happening with the plants, making them healthy, which is crucial to achieve high yields with the help of agricultural solution from us. So why do we spend more on this? This is what this slide talks about. So it's a pretty intensive, long process, like any drug innovations. So today, probably in the afternoon session, the other resource person from Pfizer may touch upon how difficult is a drug innovation, which is a long time and long investment process. It's exactly similar in crop protections. We have a years around 10 to 12 years we do in chemistry. We start from simple synthesis, kilolab development, process development, production getting ready and all. So this costs around this much millions. This is pretty old. Nowadays, it's a little bit high to 80 to 100 million. So it's always a teamwork which combines biology and toxicology people. We have different screenings in the laboratory. This all happens in Germany and US. We have screening centers there. We also do big global trials across different regions, and we do toxicology. We do extensive toxicology, which also makes a lot of money expenditure. We do test in a lot of different plants, animals, and different organisms in aquatic, algae, fish, frog, everything. And also birds, we have 10 different birds. So with all these different scenarios, we have to cross. Once we have the dossier ready, then we register and try to launch our product. So in a way, we try to make so many 2 lakh compounds, and at the end of the day, end of many years, one product will launch with this 200 million euros. I show you in the next slide, how does it go? So this is nothing but a person has to have a strong failure rate to accept it. As you could see here, 2 lakhs or 1.5 lakh substances are made by different research groups. At the end of the day, after many years, only one compound will see the end of the tunnel to become a product. So for many of our scientists to see their compound to launch as a product, it may be their whole lifetime. They may see or they may not see it, which means you have to accept the failures with folded hands and with motivation to look for more new compounds and work for sustainably for new solutions, which is not easy. People who are getting cracked due to failures, they may go out of research immediately because they may see my compounds are not active. So I'm really frustrated. I want to go out of research. But there are scientists who persist and try to find solutions. With those scientists' help only, we are able to have such products. So this figure, not only years, has become more and more 12 years. Nowadays, this figure also went up to 250 million in the last 1 or 2 years. This is what I already mentioned about this. And I would like to talk about sustainability, because these two ingredients are highly important. Chemistry as an enabler, chemistry as an industry for the whole society. So we do see a lot of plastics waste, not only in India, as I show this photo from Mumbai, but also across many places in India, as well as many other countries. So what do we do? How do we do? Not only we make this via plastic, which is biodegradable, completely biodegradable and compostable, we try to find solutions how it can be recyclable. Many of the problem comes from the polymer, which are multi-layer in the packaging solutions. Any component which is a single layer is always easily recyclable. Whenever you have a multi-layer, that becomes more challenging for recycling. That's why we see all these problems. So we started in 2019. This is our chairman, Martin Brudermüller. So we started with an alliance, a global alliance with 30 different companies. In India, we joined hands with Reliance Industries. Across globe, we joined hands with many multinational companies, and we put around 1 billion commitment to see how we can end this plastic waste in environment, in ocean as well as land. This is our commitment, and we want to work in the existing waste, as well as we would like to work on a circular economy to have all our products completely recyclable easily. So how does it happen? Circular economy means, so as of now, many of the product which comes under our production and customers in automotive industry, many of them after their life cycle, either it goes to landfill or just throw it away, littering, which happens in many parts of the country. This also happens, and some people try to do waste to fuel. This happens in very little percentage, which happens in some parts of Scandinavian countries, and in many European countries and American countries, they completely take it for incineration. So, but what we want to ensure with our global alliance is not to go here as well as not to go here, but go for a recycling, either by mechanical or chemical cycling, so that we can have more recycling of our products after the end use, after the cycle. This is what our focus. How do we want to do this? Our focus in India. So this was an announcement made in 2019, January. We as a collaboration, not only with Adani, but also with a company called Abu Dhabi National Oil Company and Borealis Vienna company. We started a commitment for a project of 2 billion euros, 16,000 crores petrochemical projects in Mundra in Gujarat. So what do we want to do here? It's a joint venture. As the four companies together, we want to invest 4 billion euros. Together with Adani, we want to invest 2 billion in this port, and we want to start a collaboration project for world-scale propane dehydration plant to produce propylene-based propane feedback. So feedstock, why do we need that? The propylene feedstock is highly essential to make a completely C4 value chain complex, which is from like glacial acrylic acid, C4 butanol, and C-ethyl hexanols, butyl acrylate and all, where there is a huge demand for that, not only from India, China, across the world. So in India, all these components are completely imported now. So with Make in India campaign, we wanted to do that and contribute from India itself to this 2 billion euros commitment. So this will not only satisfy the lot of local Indian industries, but also we may go to other countries also to export. And how do we want to do that? This is, we want to say, we want to supply this energy for this petrochemical plant entirely from renewable energy sources, from wind turbines as well as solar plant. So this means we want to have, this is the first time the whole world, we would like to start a first completely carbon dioxide neutral petrochemical site. If it is realized successfully, this will be the first in the whole world. And this will be, we are ready to have such commitment from our partners so that we have a sustainability and energy efficiency at the same time of the production which needs for the, according to the needs of the customers. And here one last slide from BSF is about Kids Lab. So not only such big collaborations, we do small time activities. We do Kids Lab across our small school kids. We invite in Saturdays or Sundays and show them what is chemistry in a simple experiment like this, you could see here, and try to give some little bit explanation. All our volunteers, bench chemists, scientists come here on Saturday and Sunday and try to teach them. And this is our small steps to encourage and motivate the future generation for chemistry learning, because we strongly feel there's a big negativity, big disconnect in the entire new generations against chemistry and all. So this is what we wanted to say, that chemistry, whenever we talk about chemical industry, chemistry means pollution, industry means bad gases and all. So we try to change this opinion, and people, it's not about, we do have certain bad companies, bad people. That doesn't mean the whole chemistry is bad or chemical industry is bad. Like in any other profession, academic or doctors, there are people good and bad. We always try to say there are good and bad. So we try to go in a good manner for the benefit of the society. So this is one way we try to connect with the school teachers. Also, we invite them and show them about chemistry to make some impact on chemistry learning. So this is last two slides about students and chemistry. This is my, maybe I'm wrong here, I don't know, but I'm just trying to share some of these things. So this is the specific question. Dr. Baby Marietta was asking me if you could share some of the thing. How do people have to, or students have to equip ourselves to aspire for work for industry? I put some 10 points. It may not be 10 commandments as the Christianity says, but 10 points I feel may be useful for all of you. I put it a little bit with some gap because many of these points are same for even if you want to go become an academic professor in St. Xavier's College or in IIT Chennai or something. Some of the points may be specific for industry. So first and foremost, of course, you need to have a passion for your subject, which is chemistry. If you don't believe in chemistry, there's no point you can work for industry or even for academic professor. And of course, strong foundation. I'm pretty sure I don't need to tell about that for St. Xavier's College students. You have a lot of good, strong foundation from great professors in the faculty and more open and creative. So please be open and transparent in your discussion. I'm pretty sure also St. Xavier's College may be encouraging a lot to have a honest discussion with the faculty and communication skills. Also, I'm pretty sure St. Xavier's College is encouraging a lot and presentation skills in your MSc and PhD. Take time to do that besides your lab work and publications and all. This is essential when you go for an interview in industry and all. Communication skills means not only about English, but also ask questions, relevant questions, and understand yourself better. Not only in a big meetings, but also one-on-one meeting. You meet a friend, you meet a senior guy, a person from company or a PhD from US and all. Try to have a communications contact and understand more and broaden your horizons. That's my advice. And these two are a little bit more useful for industry because industry operate as a good team where people work on biology, engineering, production, computational modeling. So it's always good to understand some basics of these fields like biology because it's able to communicate their language, biology or computational, so that you understand them better, they understand you better to have a work as a one good team. Adaptability, I don't need to say much. I already mentioned about that. We don't have many industries in Tirunelveli or even in Tamil Nadu for chemical. So you may need to go beyond your comfort zone, not only region, food, language, everything. This help you to go outside your place to work for industry. And last but not least, these 3 points is more about industry, practical skills. I had seen this very well in my experience in Switzerland and US. I don't need to worry about not only St. Xavier's College students, all over India, all our students from masters and bachelors have excellent knowledge on theoretical subjects. Whether you take it NMR or take about stereo electronic effects. Yesterday, one resource person was discussing. We have plenty of knowledge about that. One of the things I always felt compared to a German undergraduate student or even a Chinese, I found the practical skills is something which we are lacking a lot. We have to think how we can do internship in industry, not necessarily big industries, even a small industry like Axar Paint in Thoothukudi or some other industry in Bangalore or Chennai or Mumbai, PSF and all, how to do this in your MSc vacation, 1 month or something, 2-3 weeks. So this will give you a perspective about industry and a little bit about practical skills. Just after MSc also you can go as an internship. There are programs called Skill India by Government of India. You have to enroll there and you have to go there. And this is a third party. We try to connect young MSc graduates to the companies. That's how we took some interns from local colleges here, Skill India program. So try to have this. This will give you good internship practical skills. And last 2 points is about information retrieval. So this is very key in the modern digital age. Not only blog, we should be able to try to have various resources from Sci-Finder Alert or Reaccess Alert, Google Alert. The information is the next gold, as people say. Data is the next gold. So people who have a lot of information as in when it happens is the key to drive things in the industrial world. So last but not least, again, it may be specific to BSF or to any other industry, some basic knowledge on data handling and coding would also help you for industrial job. Because in industry, as you had seen, millions of compounds, we deal with that. So the data we generate is huge. So we need to have some understanding of handling this data. If you have such knowledge in basic knowledge, it will always help you. One more last slide, some suggestions for curriculum in organic chemistry. which again, Dr. Baby Mariatra had mentioned it. These are some of my points, which may be right or may not be right. The next speaker from the next resource person from company from Pfizer and US may also agree with me, or they may have different views. This is my view. First and foremost, I try to point out is about safety and sustainability, because again, chemistry is considered as a negative reputation in the whole world. We all need to be very much about safety in synthesis. What is GHS, Global Harmonized System? Even in undergraduate and postgraduate, we need to know what is TT plus chemicals, toxic chemicals. What is meant by CMR, carcinogenic, mutagenic, reproductive. So we need to identify these from the labels, and we need to understand all these chemicals when we are using every day in our labs. So this sort of impacting safety is not only good for our health and people surrounding us, but also trying to give a good spin, good positive spirit about chemistry to the other people around non-chemistry people. You could read a lot of case studies from journals like Journal of Chemical Health and Safety and many other magazines, and discuss among that within your team and group to enhance safety knowledge in synthesis. This is my suggestion. Even in your curriculum, sustainability, you might have these topics: green chemistry, carbon dioxide reduction, circular economy. If you would like to add more, I don't know whether it will fit in bachelor's or master's, but wherever it fits, if you can add some more points, it'll be useful. These are some of my favorite topics in the organic chemistry in the new area, photoredox catalysis, not only by Professor Macmillan, Professor Koenigs, but also from industry like Merck, which they are putting a lot of effort in this research and trying to have utility in our day-to-day research. CH activation, biocatalysis, electrochemistry, I had seen that you are doing that in your curriculum. Dr. Baby Mariatra had shared with me. At the same time, some recent examples from Professor Phil Barron and other big people could also be added to have recent examples. These two are typical of medchem discovery as well as agro discovery. Late stage modification of small molecules. There are new tools being published in the recent years which could be added. And these are some of the technologies which a little bit some basics in masters or PhDs, if you are familiar with it, may help you when you are getting prepared for the industries. Fragment-based discovery, cryo-EM techniques. What about protein-protein interaction, disrupting them? PROTAC means proteolysis, targeting chimeras in the proteins. So these are some of the new jargons, you can say, or new techniques, but at least a little bit knowledge may be helpful when you get prepared for industry. Last, this is our BSF chemical complex slide, which is in Ludwigshafen in near to Frankfurt. And my acknowledgement to first to Dr. Baby Mariatra, and my humble respect and thanks to principal, vice principal, and head of the department to encourage the faculty as well as the students to listen to this topic as well as benefit out of it. Thanks all the faculty members to support this program. Thanks to all the students who listen and enrich your horizons, knowledge, and thanks to all the participants in this webinar. Sorry, I took a lot of time. I am very sorry for the next resource person. So I will stop here, and I would like to take a few questions. And if you want few detailed discussions, I'm ready to have some other discussions in a separate meeting later so that we can park it there so that we don't make our next resource person not wait for a long time. Thank you. Thanks all.
Thank you, Dr. Valinayagam. Now I invite our Professor Jaykumar. Professor Jaykumar.
Ma'am? Yeah, ma'am.
Yes.
Good morning.
Yeah, he wants to thank Dr. Valinayagam on all of our behalf. And after that, we will have few questions before moving to session 2. Already Kaliappan Muthukumar is there in our meeting. So let's start over to Dr. Jaykumar.
Thank you, ma'am. I take immense pleasure to thank our vibrant speaker, Dr. Ramakrishnan Vallinayagam, for his insightful presentation about the role of BSF India, especially on innovations and sustainability. Despite the COVID pandemic, I really anticipate to thank you, sir, for accepting our invitation and presented the role and significance of BASF India, that too with a very great enthusiasm. Thank you very much, sir. The divergent role of BASF India in the fields like ammonia production or any chemical production and are very really cool, sir. Especially the agri solutions, sir, seems to be very cool, and we're looking forward to visit your place, sir. Sir, your presentation, the whole way you carried the presentations seems to be very attractive too, sir. With this, I personally like your Plan A, Plan B approach in the strategy design too, sir. I'm sure this session would definitely inspire many budding research scholars, student community, and above all, sir, this would indeed help to increase our vast knowledge. And we are really looking forward to visit you on your place, sir. Thank you very much, sir.
Welcome.
Thank you very much, sir.
At
One
any
more
point
time.
of time, please
Yeah.
just mention me if you visit Mumbai, if you would like to visit our campus. Not only you, all the faculty members, students, always
Especially
welcome.
students. Yes, sir. Especially students. We wish to
Yes.
send students for academic, industrial visits. Thank you very much, sir. Thank you. Thank you very much.
Welcome. You're always welcome.
Over to madam.
Dr. Valinayagam, I'm also impressed by the way, you talked about your plan A and plan B. If I am correct, always your plan B worked out very well.
I didn't know what is my plan A. Maybe I choose wrong plan A.
Maybe, man proposes, God disposes. Maybe that is God's plan that plan B should work out for you. And this is the word after my marriage, this is the word I used to hear, till now, plan A and plan B in every occasion. And now I know what is the inspiration of plan A and plan B. Maybe it comes from you. It's only coming from you to my family also. Thanks a lot, Dr. Valinayagam. You have covered everything that we were planning, and it was a wonderful presentation. It was a wonderful information you have provided to us. And we have some 3-4 questions raised by our faculty members and our MSc students. So I will try to unmute them. If they are not able to talk, I will ask the questions on their behalf.
Go ahead, please.
Christopher sir, you are unmuted. And Ruben sir, please unmute yourself. Participants, if you have any queries, please raise your hands. I can unmute you. Before that, I will go to the registration form, and there are few questions.
Yeah, please give preference to the students.
Yeah, I think Ginil Moon is there to ask.
Yes.
Yes, yes, sir.
Good morning. Thank you. Good morning, organizers for.
Sir, I'm not able to hear you.
The speaker for giving such an insight into the industry. Okay. So my question is, what is the procedure for students, our postgraduate students having internship or any sort of training in your company?
So we have 2 sorts of internship we provide. One is during MSc, during their first semester or second semester break, few weeks. It may be just 1 month or 2 months. We provide not much. We already provide 5-6 students and provide them this internship for a month or 2. Okay. Another internship is after MSc, after fresh MSc, we provide around 10 MSc people from colleges nearby. So they all connect with in the Skill India program. They connect with the local or the third party who collect such applications and share with industry. Then we interview them quickly in a WebEx or Zoom and try to have them for 1 year internship as a trainee, where we provide some internship money, and that's how we have around 10 people in our campus in my group to do that. Yeah.
Okay. Is there any possibility for research exchange or exchange of research scholars between our research centers and your R&D?
We never thought about this. These are good suggestions. So far, we had some of our people who are doing PhD, in-house PhD, but connected with IIT Bombay and NCL Pune and all. But so far, we never had any exchange of a month or two between academic and industry. This is a good suggestion. So far, we had exchanges between our own sites, between India and Germany, India and China. We send our bench chemists and scientists for 1 month, 2 months. So they also come here and all. We had such exchanges, but so far we never had exchanges between academic and all. But it's a good suggestions. So if you have a right proposals and right candidates for a short term, why not? It's a good point. I would agree.
Okay. So thank you, sir. Thank you for giving us the ideas. So
Okay.
thank you, ma'am. Thank you.
Thank you, sir. We shall quickly move on to the next person, Muralidharan Balachandra. Yes?
Okay, ma'am, this is Ruben.
Yes, sir. Yes, sir.
Okay, so I have one question towards our speaker. Dear sir, apart from academic excellence, what are the skills our students should gain to work in industries like yours?
So I try to cover.
Is it clear?
Yeah. I try
Hello,
to
ma'am.
cover.
Yes.
Dr. Ruben.
Go ahead.
Hello, ma'am. Is it audible?
Yes, sir. You can go ahead. Dr. Valinayam is responding to your question.
So, Dr. Ruben, thanks for your questions. This is what Dr. Baby Marietri also asked me. I try to put many of these points which comes to my mind so far. So these are the points which I discussed. It's not only good to have, but also essential to have for aspirations to work in Indian industry. Yeah?
Okay. Shall we move on to next question by Muralidharan? Sir, Muralidharan, sir, you are unmuted.
Yeah. Good morning. Good morning, Mr. Ramakrishnan.
Good morning.
Yeah, it was really like inspiring and interesting presentation.
Excuse me while I'm having coffee at my home. Huh? You can
carry
on with your question.
Please. Yeah, I have two questions. How far BASF has switched over to eco-friendly insecticide or herbicide production? And the second question is, do you think that 100% eco-friendly insecticide or herbicide is achievable?
Very good point, Dr. Muralidharan. It's a very good point. One is, see, we don't talk about compliance to the country standards. This we always achieve. That's why these products are there in the market. We want to go beyond the compliance required for the country. So one is about the quantity which we use. So recently we have a product called Inscalis, which is launched in cotton farming in Chandigarh and Punjab. So this is the first time 5 gram per hectare, 5 gram, which is just within your hand. For a whole hectare, it can control all the piercing sucking pests. So far, the older nasty insecticides, you need kilogram per hectare. Please note very carefully, kilograms per hectare. This compound with 5 grams per hectare with very less quantity is able to control the same area, number one. Number two, in terms of complete 100% eco-friendly, what does this mean by? So there are certain pests, certain crop which needs different solutions. So for example, in apple industry, apple farming, in codling moth is a chewing pest which is making a lot of damage, 40% damage to apple. This is controlled in whole Europe most of the time for our product, which is nothing but a pheromone, which is put as a pheromone. It's a hormone from insect, which is kept, which disrupt the mating. That's how the population decreases and no damage happens. This is completely a biological solution. This is not a chemical something like that, which is applied all over the field. Now, what I'm trying to say is this solution cannot be applicable in every pest and every crop because it depends on different pests and different crop. So you need certain solutions where you can control by seeds, hybrid seeds. For example, wheat, you don't need to do genetic modification. The hybridization of wheats itself gives fantastic solutions. So we depend only on hybridization, not genetic modification. Whereas in corn and soybean, you need genetic modification to control of the weeds and some of the nasty pests. And somewhere some solution needs not genetic modification, but just chemical solution. So you need to find out which crop, which pest needs different solutions and how this can be obtainable by more about eco-friendly. So we have a not only when the compliance asks for honeybee beneficial insect screening, we do that in bumblebee, we do that in earthworm, and every organisms to see the safety of our products in all these organisms beyond what the regulatory body asks us to submit the dossier, so that our products can be highly friendly. So for this, you need a lot of challenges in chemistry as well as biology. You need to identify the protein which is more expressed in the damaging crop pest, whereas less expressed in honeybee and bumblebee. So that's why we need to find out all these differentiating factors deep inside, very detailed, to find out these differentiation factors and address them with chemistry there. I don't know whether I'm able to address complete all your questions. This is what I could say in a nutshell, how we are trying to address in terms of environment friendly products from us.
Thank you. Thank you for your wonderful explanation, Mr. Ramakrishnan.
Thanks, Dr. Murugan.
Next, we will move to our MSc student. Richu, do you have any questions? You raised your hand.
Yes, ma'am.
Yes, please go ahead.
Thank you. Thank you, sir, for the most beneficial and informative talk. A doubt that I have is, as a chemistry graduate, a fresher, what is the probability to get placed in these companies, sir? We are in the first year and we can't go any internship for this year. So what is the probability for getting placed in companies like this, sir? As a fresher.
To find probability statistics is more challenging. And how much percentage it comes. So my advice as a young fresher, like I was 25, 30 years before, my advice is simple. Just have your strong foundation in theoretical chemistry, very strong foundations, number one. Number two is please get connected to all your seniors in chemistry. Where do they land up? Whether they land up in US, like my next speaker, as a industrial job in US, or in industry in India, or an academic professor. Please connect with all your seniors so you know better how people make different decisions and how they get different exposures. Even if not, you cannot come to Chennai or Mumbai or Bangalore or US, doesn't matter. Even at least find in your locality how to connect people. So I can also tell Dr. Baby Mariatra some of my connections in local to connect with industry. I have a good friend working in Axar Paint. He's in charge of Axar Paint in Thoothukudi. And I also have a good friend from Sikri and South Korea, corrosion expert, corrosion inhibitors expert, who is in Tirunelveli now. So I could connect all these people. You also, whenever you come across certain seniors who does such experiences from your college or your connections, connect with them to understand what you need to be equipped beyond the theoretical chemistry, which I'm pretty sure you'll get equipped from St. Xavier's College. Not only that, communication skills and presentation skills. When you have all these skills embedded in your day-to-day life, then things will fall in place automatically if you have the right contacts and get more understanding. I don't know, I'm not able to give you very clear probabilistic percentage, but these are the skills. If you try to do this methodically, things will fall in place automatically, I would say.
Thank you, sir. Thank you so much.
Thank you, Richu.
Hello, sir.
Yes.
This is Christopher.
Yes, sir.
Sir, I'm really impressed with the seventh point, adaptability outside your comfort zone. Mostly we people fail in this area. Sir, I have a question. You said you have molecular modeling and a data analysis branch in your company. Let me know the scope of studying chemoinformatics and bioinformatics. Because a decade before, it was more wanted one, but even some colleges have started bioinformatics. But today they have they canceled that program. Let me know the scope, sir.
Thanks, Christopher. Thanks for asking these questions. So what we have in molecular modeling is purely a molecular docking experience, mostly using the knowledge of bioinformatics. In data analytics, we do have certain tools for Schrodinger and all to do data analytics. And also we have quantum calculation expert in computational to do certain physiochemical property prediction of many of the compounds and the end product which we manufacture, we prepare. This is one aspect. We do have bioinformatics expert, quantum calculation expert in computational to support our synthesis group. Now, if you ask for in terms of how is the future, how is the focus in future, I would say chemoinformatics we don't have, but we have it in our corporate headquarters in BASF Ludwigshafen. We have a big team of chemoinformatics. Now, if you ask me bioinformatics, artificial intelligence, deep machine learning, and deep artificial neural network, a random forest method, all these things have a, I do strongly believe there's a big future for it. Not only for chemistry, every industry is having huge data, whether you take it as a geo SIM card or geo data, or from material industry, or for pharma and agro. Every industry has a huge data to analyze them and understand them better. So if you have this bioinformatics and data science knowledge using artificial neural network or any other generative models, you always have special exposure and skill to understand this data and come to a certain conclusion. This is also a big field happening in terms of bioinformatics. Also, people try to understand the genetic informations quickly and try to find out certain mutations in certain organisms, why it's different, and what different natural product it may synthesize and all. So I strongly believe this will have a future. This has a future in different industries, more in data science and also in some extent in molecular modeling and bioinformatics, I would say.
Thanks, sir. Thank you very much.
Thanks, Christopher.
One more question, Mr. Ramakrishnan. I am Professor Murali. Can I ask?
Yeah, please go ahead.
Yeah, like one of my research scholar, he has developed 4 flame retardant mortars, which are able to withstand a very high temperature of 200 to 210 degrees centigrade for even 1 hour.
Mm-hmm.
Yeah, is there any chance that we can collaborate with BASF? Maybe like you may have a division, building materials division or something.
Yeah, please,
If you can,
please share with me. We do have already collaborations, not in my group, another group, but I can connect you with the right person so that
please.
we can talk more.
Yeah, it will be very beneficial to us.
Definitely.
I am a former professor of BITS Pilani Dubai campus here in Dubai.
Okay, thanks.
Yeah.
Thanks, Professor Maridhan. And I'm ready to connect with you to the right person.
Please.
So we can explore more and see.
That
We
would be
always
very...
welcome any such ideas. We always welcome and try to work together. Thanks, Professor.
Thank you. Thank you very much.
Thank you, sir. Muralidharan sir, thanks a lot. We feel satisfied when, it's a place for collaboration.
Yeah,
And
thank you, Dr. Bibi.
thank you, sir. Thank you very much.
Thank you.
Shall I mute you, sir?
Yeah, please. Thank you.
Yes.
Thank you very much.
Yes. Mr. Shaktivel, do you have any questions? You raised your hand, but unfortunately, I was not able to, unmute yourself. Do you have any question, Mr. Shaktivel? Okay, I think he's not able to connect with us now. Okay, thanks. So with this, we will move to session 2. Dr. Kaliyappan Muthukumar is with us. Dr. Valinayagam, please be with us for some time if you have free time. And thanks a lot for all your effort, all your interest, and it's a really wonderful blessing that we had. Now, thank you very much, Dr. Valinayagam. We shall chat again regarding our academic progress. Thank you very much.
Bye.
Thank you. Bye-bye. Bye. Next, I call upon Dr. Mary Jalestin Kala to introduce Dr. Kaliyappan Muthukumar, the industry expert from USA, to talk about his industrial experience. Welcome, Dr. Kaliyappan Muthukumar. Now over to Dr. Mary Jalestin Kala.
Once again, I am pleased to introduce Dr. Kaliyappan Muthukumar, scientist, Applied Materials, San Francisco, USA. He completed his BSc in Sattur, MSc Chemistry in Bharathidasan University, Trichy, and PhD in Tyndall National Institute, Cork in Ireland. He carried out His postdoctoral studies under 3 different universities of USA and Germany under Marie Curie Fellowship and Beilstein Fellowship. Dr. Muthukumar is an expert in materials. He is a well-known scientist in modeling process chemistry and device, physical and applied materials. He is a process modeling professional in semiconductors. He has more than 20 years of experience in modeling materials and chemistry for advanced nodes like metal gates, atomic layer etching process conditions for conformational doping and design of new materials for PEOL, BEOL applications for sub-10 nanometer nodes. He has proficiency in stimulating process conditions for advanced thin film technology such as atomic layer deposition ALD and chemical vapor deposition CVD of high K dielectrics and metal gates. His expertise in modeling diffusion, activation barrier, molecular dynamics, Mond correlate techniques, atomic layer deposition, electronic structure defined chemistry, bulk resistivity, crystal structure protection, etc. He is also experienced in handling big data, Hadoop, SQL, HIV, Yarn, Python for data services, etc. Now, I invite the multi-talented scientist, Dr. Kaliyappan Muthukumar, to share his experience with us. Welcome, sir.
Thank you, ma'am.
Yes, we are able to see you in the screen, Dr. Muthukumar.
Yeah, that's fine. I can share my screen. Okay, so can you hear me?
Yes, sir.
Thanks for the great introduction. So I'm Dr. Multidisciplinary Scientist. Let me see. Wait a second. Yep. Oh. Hello?
Yes, yes, we can hear.
Okay, that's great. So thanks for the nice previous talk. So that has covered lots of things that I planned to talk in principle. But anyhow, I'll try to cover rest of the things like in the terms of view of a student of a MSc or a BSc student or the PhD student. I'll try to address like what are the possible things that we need to take care of to enter into the industry or to excel in academic or to become a good scientist. Okay. I'm a scientist at Apply Materials. Apply Materials is a company that not many people are aware of. So what we do is like we provide manufacturing tools which make chips, the integrated electronic chips. So Intel, Samsung, TSMC are like our customers. So we are the first company to start that, and we are the leader on that. But since like we are like a developers for the products rather than the end products like what Intel or the Samsung makes, we remain silent in most of the case. So in this talk, I'm not going to talk most of the things that what Apply Material does, because it does many things. But I trying to spend my time with the students to interact more on how we can get their career efficiently improved. So let's start from my introduction here. I mean, I got a good introduction from the professor. I just wanted to go through again. Um, I hope you can see my screen. So I started my BSc chemistry in 2001. I finished my BSc chemistry in 2001 from Satur. So Satur is a close by place for you, maybe like 1.5 hour travel from now. You have to cross my town to go to Madurai or to Chennai, both railways and roadways. So then I moved to Bharatidasan University, Trichy, where I did my MSc chemistry. That's why where I met many people, great people here. And then after my MSc, I was like working as a scientist in Jubilant Biosys. Here, I was working as a chemoinformatics. I mean, informatics is like you carry kind of electronic format of your structures and then create a database out of it and then make that helpful for the real world scientists for the easy access of the chemical literature and other stuff. Okay. Then I got my PhD. I got a place for my to do my PhD at Tyndall National Institute, which is popular for after the scientist Tyndall who discovered Tyndall effect. And he got like a Marie Curie fellowship, which is like a highly competitive one. And then after finishing in 2009, I went for like a postdoc. I was working as a computational catalysis, and then I was working as a electronic deposition methods in Frankfurt, Germany, and then doing lots of simulations in Atlanta too. And after finishing, I was working at the scientist in Bay Area. So, I mean, everybody know about the Silicon Valley here. So Silicon Valley is like, we call here as a Bay Area, which means you have like a kind of place which is covered completely with the bay here. And that's for prone for innovation. So the first electronic chip or the transistor was discovered here in this area. And Intel is here, Apple is here, not the fruit Apple, the company Apple. And Applied Materials is also here. And we are like next neighbor company to the Apple. And AMAT is like spread all over the world. In India, it has 4 branches. It's in Chennai, Bangalore, IIT Mumbai, and also in Noida. I mean, all these chemistry processes, they were done in IIT Mumbai branch. So this is the main headquarters is Santa Clara, where we have all kind of chemical things also going on. But the sub branches, like more 95% of the work is done by the people here in IIT Mumbai. This is a clear background of applied materials. But what we do in terms of material science. So what is material science? What is nanotechnology? Many people were aware of the word nanotechnology, but nobody knows what nanotechnology means. So if I just wanted to explain something before I explain what's nanotechnology here. So this is a kind of graph that explains number of transistors in an electronic chip over the years. Okay, if we start from 1970 and this is like 2005 and we are like now 2020, this is the number of transistors. Okay, so as you go to the 1970 to 2005, we see that the number of transistors keeps on increasing on electronic chip. Okay, so this is called a Moore's law. This is the great slogan for growing of electronics here. Those people who do not know about Moore's law, I mean, please know about it. This is almost dead now, which means like we are trying to produce more transistors on electronic chip, and more the more they become very smaller, it's difficult to get processed. I mean, we have to make the chips, right? So it's almost dead. We are trying to find out new alternatives on how to improve the transistor. I mean, what is a transistor? Okay, you use mobile phone, use a laptop, use like a television and everything. Everything has a transistor in it. So it's the basic component here in the electronic industry. So my chemical background and materials background is to define chemical processes or to simulate such chemical processes where we can be able to deposit uh, for the small technological nodes. I mean, right now we are looking at the nanometer scale level where we deal with the atoms and molecules, mostly atoms. So when you use a technology out of atoms, we call it as a nanotechnology because the atoms are like 10 to the power minus 9 sized molecules. Yeah? So that's how the word comes as a nanotechnology here. So what I mean, the nanotechnology is in effect even like even after 2000. There are like many kind of transistor, single molecule transistor, or like a couple of atoms based transistor, and so on. Here we use kind of terminology which is called N10, N7, N5, N4, which means like the 40 nanometer technology, 10 nanometer technology, and we were up to now like a 2 nanometer scale. We are working up to like 2 nanometer scale. So I mean, we have dealt about nanotubes and also like graphene and other nanomaterials, but nanotubes have never made into the electronic industry. But like graphene, we are still trying. But more recent materials are the like 2D materials, which is like the graphene shaped molecule, which is a plain sheet, but it's made up of like a heterogeneous materials like tungsten diselenide, tungsten sulfide, tantalum, silicon, etc. Okay, so this is the major thing we do for the industry, electronic industry. Okay, so if you look at the process, what defines all this is a basic chemistry and basic physics and basic electronics. So nothing comes separately. Everything comes in a multidisciplinary mode. So you have to be like understandable of capable of understanding what's going on in terms of physics, in terms of chemistry, and even in terms of electronic structure simulation, which is the theoretical chemistry. So it's like an overall effect. I'm not going to talk about this too much now. Let's focus on what the student need right now. So what I'm going to talk about is applicable for all the branches of chemistry. So people are aware of organic, physical, and inorganic chemistry, and to some extent biochemistry, some extent nanomaterials or materials chemistry, and other extent computational chemistry. And there are also several environmental, forensic, industrial, textile, food. So these are like basic chemistry modes, and some colleges offer specialization. And if you take specialization courses, it's very easy to easy to get onto the specified industry. For example, if you took like a forensic chemistry, which is offered by very less number of institute in the world or the India, you can still get qualified for the forensic based jobs in India or also in abroad, depending on how you profile yourself. Or also like a textile. Yeah, there is like some colleges where they are specialized on textile chemistry. And if you even in Tamil Nadu is very popular for textile industry, you can even get into many good jobs. And also like food chemistry. And the recent thing is like materials and computational chemistry. My background is computational chemistry. I can talk like for more than 3 hours what we can do, but we will do like one more session, separate session. But we will discuss about like what does MSc chemistry student really needs out of now here. So in chemistry education, yeah. So when we have kind of a chemistry education, we have kind of a traditional route. So we blindly go for BSc. I mean, people come for BSc even without knowing that they are interested in chemistry. So whoever interested in chemistry further, they go for MSc. And after MSc, MPhil. MPhil is not really needed these days. And you can go for PhD directly and postdoc and job. So what's postdoc? We will discuss later. So if you really wanted to go to industry, or if you really wanted to land a high qualified job, it has to be started very early. Okay, so how can you start? So if you are a BSc student, I would say if you are a BSc or a MSc student, you have to be very good at English. Why English? English is a communication language. Right? So you have to be like very polite and very communicative in English. I mean, I'm not suppressing our local language, but English has become a common communicative language all over the world. Okay, so when we are speaking about the international level, we have to talk about international languages. Okay, so and also the teaching and soft skills. So what's teaching in the MSc and BSc? So try to make as efficient seminar as you can when you get a chance, and try to make soft skills. What soft skills? Soft skills is like how you respond your difficult situations politely. Like for example, how you help your people around, how you respond to your teachers, or how do you enhance your like very polite skills. Okay, so I mean these are not directly linked to your um, industry landing of a job in industry, but this will help always. Okay, and you have to be like a subject wise. For example, be curious. If you observe a process, try to understand scientifically, yeah, why this happens, yeah, why this happens, what chemistry is behind it, and why can we repeat that chemistry can we observe that chemistry in a different natural processes, and why, and try to learn some kind of IT coding. What's IT coding? Yeah. So, I mean, when we were studying computational chemistry, we were learning about Fortran basics and also C++, etc. So, I mean, until last 5 years, there are many codes even written in Fortran. But these days, everything is replaced by Python. Python is as simple as possible. So it's like it's even like a 10th grader can excel in Python. So try to be very handy at coding, or try to be computer educated. The reason why is like chemistry is not only chemistry; it can also be extrapolated to different markets, and you need to be computer literate. Even like a basic Microsoft Word and the Excel, you have to be like a advanced user and get, I mean, if you plan to do like a kind of research in your later future, in your later part of the career, try to be like get exposed yearly. Okay, so how do you get do internships? How do you get internships? That's the last, I mean, I see lots of people are trying to get this kind of things, I mean, internships that can be done both in the academic level and also on the industry level. I mean, at BSc and MSc level, don't hesitate to go any of these things. Okay, so it's really hard and competitive to get into the industry level, but you can always approach your professor in a nearby college or a university, and you can go and spend like 1 or 2 months in your summer time and try to get like a exposure. What does a research mean? What the research people are doing, and what they are doing in the laboratory, what characterization techniques they are using, etc. Okay. So if you're interested in PhD, I mean, I would say that you start from like start trying to clear the CSAR and GATE exams. I hope you know what they are. The reason why you have to have CSAR and GATE exam, I will talk to you about it in a while. Okay. So after MSc, you can have like a two kind of route, like one is academic and industry. And if you really wanted to have excel in academic, you have to clear a couple of tests, which is like CSAR GATE, which is subject wise. You can also try to be focused on IELTS or TOEFL, which are like an English test, and that gives you like a score for your reading, listening, communication skills, etc. There are four branches: reading, listening, writing, and reading, writing, listening, and speaking. And GRE is like a subject GRE. So once you clear CSA or GATE, this GRE is very easy actually. And then IELTS TOEFL, that comes with the practice, and you really need a hard work because English is not our first language. Okay, even if we can speak fluent English, English is not our first language. Our first language is like our local language. So if you really want to excel in industry, try to identify like your interest yearly. Okay, try to do internships in the industry. Even if you don't get in industry, don't waste your time. Go into the academic setting and try to learn what the people are doing, and what the main problem. What the main interest you need is like the experiment planning. For example, what is experiment planning? If you have some idea in your mind that this reaction is very new, or you can produce the same product in a different route, you have to make that to work. Yeah, so you have to design an experiment how you can do that. And if you don't have a chamber, you have to design a chamber, and then you have to plan for a characterization technique. So this comes with the experience. Okay, so these are the skills that you need to excel in academic and industry settings. Let's go this academic and industry setting one by one in a detail. So what's academics? What's life after MSc? Okay, so this is like the more confused stage, because we know that MSc is okay, and then we didn't. If we qualify CSAR and GATE, we will be able to get our funding for our research, and you can also go for PhD in IIT, ISR, IACR, which is like a also the similar kind of qualified institute like IITs and like abroad also. And there are like several CSAR labs also you can try, and also state and universities, state universities and private universities and colleges. And if you have IELTS and TOEFL, you can try for PhD abroad, fully funded, which is always comes with the fully funding. And before you go to the international research, it's always better to have some kind of experience at a national level. So this means like this can help you to get competitive with the people working in your lab internationally. So let's go by one. What is the important point? Why CSAR gate is important? So, I mean, you might have lots of knowledge in chemistry, but you need some kind of sheet that explains to the people that you have a knowledge. Okay, so you can't always demonstrate your knowledge to every people. So if you just say that I have like a CSR gate clear, that will give you accreditation in a fraction of a second. And what the beautiful advantage of this examination is, like, it gives you kind of funding for your research at national level. So you get paid for your research. So you don't have to like worry about your stipend. It's like a kind of a job that will get you funding for at least next 3 to 4 years without any problem. And then if you have like a CSAR gate and if you have like a internships, then it will help you to land in a reputed labs here. So what's a reputed lab means, like the success of your PhD is monitored by two terms. So one is how easily you can finish your PhD, how qualified publication you can make, and how much is your PhD useful for the people or for the global kind of environment. So if people are like, there are like several dedicated professors spending their life to advance the human life standards or for the different kind of problems like people are doing for now for COVID. You can try to address some kind of problem like that. Okay, so once you have the CSA or a gate cleared, it's also easy to clear like a government-based jobs. Okay? I mean, when we are talking on this forthcoming slides, we are not touching anything based on government-based jobs, which we get. Like, for example, you finish BSc, B.Ed, and then teacher, MSc, M.Ed, and then teacher. We are not talking about this kind of basic job. This is what we are talking about. It is like a kind of how you become a qualified chemist. You know? So what's a qualified chemist? So you are trying to be like a leader in the field, and how to become a leader in the field. Okay. So the first thing, if I mean, since we are like located at a different places in India, only the people in city or the people in the developed places, they are able to get access very easily, rather than the people living in a kind of urban places. You know? So the best thing I would say is like, even though the people are in urban place, they might have good knowledge and more dedicated time to learn chemistry and kind of a good subject oriented thinking. Uh, it's better they can concentrate on these exams rather than getting a focusing on internships or focusing on traveling around. Try to get these exams cleared, and with the help of your professors, you can be able to get at least move from your own place to the nearby city or town. That's your first step. Yeah. So don't think too much. Just get out of your hometown. And when you go out of the hometown, you need to have a funding for, I mean, source for funding. Yeah? So this test will definitely give you about it. So then why do you need a PhD? You know, PhD is like you cleared CSR exam. Okay, that's fine. You have to utilize that in the right way. Okay, so I mean, I know several people who cleared CSR and GATE and never went for PhD. You know? They went for business, or they went for like other studies or for teaching, etc. So if you have a knowledge to clear CSA and GATE, I would say that definitely go for a PhD and go for a right lab. Okay, so what PhD gives you is a knowledge and recognition, and it gives you an idea platform for broadened thinking. So if you have a PhD in chemistry, you really don't have to work for chemistry for a long time. Yeah. So once you know the way of how to publish the results or how to do your research, then you can do the research on whatever the field you are interested. For example, I did my PhD in chemistry, but now I do research in biology. I do research in geology. I do research in astroscience. Yeah? It's up to you to what you can publish. So it just broadens your thinking and opens up area for more research level, more research opportunities. Okay, if choice exists, choose your topic wisely. So what does that topic is? This is what the previous talk was addressing to. You know, so what's the topic? If you're interested in kind of going to the industry, most people are interested in people with the organic chemistry background. Okay, so why organic chemistry? Because you are involved in lots of characterization. Okay, suppose if you are interested in kind of solar kind of research, you know, then physical chemistry is important. I mean, inorganic chemistry is important. So the materials based on inorganic materials are used for the solar research. So based on your interest, choose your topic wisely. Don't just go behind organic chemistry. Just have a feeling that it helps you for the industry. Choose your interest. Okay, so if, for example, if you are interested in physical chemistry, you can also do like a kind of more kind of synthesis of precursor molecules, or for solar water oxidation, or kind of materials for materials for solar cells and etc. They also need kind of synthetic and other characterization techniques similar to organic chemistry. But organic chemistry is preferred at the initial level. For example, if you finish your MSc and then if you want to go for the industry right away, organic chemistry is a kind of a tag that helps you to get a job immediately on that. It's also for the inorganic chemistry and physical chemistry, but it depends on what research you do. I mean, what kind of project you do and what characterization technique you resemble. But there are plenty of opportunities if you know the basic chemistry and you know the basic synthetic techniques or whatever you were suggested in the MSc project. And if you're good at like a kind of communicating with the people about your research and your chemical knowledge, that will definitely land you in an industry job. So what's a special magic word about PhD is like start early and finish early. So if you start at the age of like 22, which is immediately at the age of 22, which is immediately after your MSc, even if it takes like 5-6 years, you'll end up getting a PhD in 27 years. So that's even relatively quite easy. If you finish your PhD before 30, I mean, I'm pretty sure that you will. This career is not a short time career. It's like a long time career, so it will take a long time to get settled. So you need, if you have energy to finish it early, then you will have energy to do more excel on the, make more publication, more research, and more to get efficient jobs in the later stage of your life. Okay. So international PhD. So this is a kind of my specialization. For example, people are thinking about labs, national labs, IITs, IACs, NICEs. Okay, that's fine. Are these researchers or international level? Okay, yeah. Some labs are really doing very good at the international level, but some levels are not just they're not just the fact that they are located at IITs. It's not a matter of fact that you are doing a very good research. Okay. I'm not complaining about the people or anything, but it's just like when it comes for PhD, the institute doesn't matter. What matters is like your interest and how you interact with your supervisor and what productive thing you are making out of your what productive publication you are making that's useful for the global mankind. Okay. When it comes for abroad studies, for the international studies, you can do either MS or PhD abroad. Okay. So in principle, there are several funding scholarship available for PhDs, but they are limited for MSc. For example, you have to pay money to get fees paid for your MSc course, and then later you can work part time in the outside the universities or at the universities, and then you can get your fees collected. But MSc M Science is the place where you have to like kind of focus more on understanding the chemistry and then develop your base strength. Okay, so I don't recommend doing M Science outside. But if you end up in USA, or if you have caliber to end up in USA for doing MS chemistry, I would definitely recommend that, because the reason is like you can get converted the period that you spend for MSc towards your PhD later, which means like you do MS for 2 years and then PhD you can get it for 3 more years. So in the 5 years you'll get like both MSc and PhD. That happens only in some selected countries, and it needs your supervisor's help. So when it comes to PhD, you can do some PhDs at several places, and it's mostly often completely funded. They take care of the tuition fees. That's really competitive. So you have to be like a you have to develop a caliber, both in English, subject wise, and also the way how you work and how you interact with the people. So everything is depend on like your own interest. Okay. Um, One thing before you try for international PhD is like what I would say is like you try to get some experience at state or national level experience, because when you come for international level, you are competing with the people who have a very good background in subject and also how to handle the instrument at the competitive level. For example, here in USA or in Germany or in some European countries, people at BSc level or at the bachelor's level, they do work with the people who do postdoc or kind of independent research. So their knowledge is much more advanced than our PhD students. So it's better like we get some experience at the state or national level before we end up getting an international lab. That will help us to get like a kind of different different atmosphere and also like a different experience. And being competing with the international people gives you confidence, right? And PhD, like people talk different perspectives. Say that there are if you if you Google around, people say people have different perspective for PhD, but it's a nice challenge. Okay, I mean I would not recommend for the people. PhD is like you can do at any time. Even people at after 90 have ended up getting a PhD degree, and even after 100, yeah, that's possible still. So it's up to you. How do you challenge? How do you take the challenge? And how do you face the problem? How do you put your knowledge? So the study has, or the education has no limits. You can study at any time. And if you come for like an international lab, it's recommended that you don't choose any country, don't choose any country, but some selected countries, in principle, some developed countries that can help you to get job in India, on also like a good, give a good recognition when you move around the place. You know? I'll tell you some quick examples here. For example, in Asia level, you can do it like India, Singapore, Japan, South Korea, Taiwan. These are the countries that are very popular for like international PhDs. And in Europe, there are several places like Ireland, UK, France, Germany, Spain, Portugal, and also Netherlands, Holland, Denmark, Norway, Sweden. So in principle, Europe, you can go anywhere. In Europe, it's a good thing is like we'll also get up some kind of international fellowship. For example, I ended up getting a Marie Curie fellowship, but it's really competitive. You have to have a good research proposal and the background matching the proposal. So it's better to work somewhere before you apply for that. So PhD, even the good thing with Europe is like you can finish your PhD in 3.5 years. Okay, in India it goes like 5 years, anywhere between 4 to 8 years, and even more than 8 years. So if you do part time, But in Europe, it's mostly like you will be able to finish it in like 3 to 4 years, for sure. And USA is a top leading place for PhDs. It's like more like an Indian PhD. It will take 5 years for you to finish. But if you come for MSc, you can get converted to PhD. But getting a place and funding is always a challenge in USA. But if you end up in high universities like Princeton, Stanford, you can always like get a good recognition. It's a kind of like you get settled in your life after your PhD. There are several, you will work in a high qualified projects, and then you can easily absorbed by the people working around in the industry around that area. So how do you approach the people? How do you get the PhD? How to start? I would say that when we started applying for international PhDs, we didn't even have, that was the time when internet started. We even paid like 50, 60 rupees per hour for internet. But these days, internet is available everywhere, and the software is a LinkedIn, right? So LinkedIn helps you to connect people and different professors. So be gentle on LinkedIn, and also smart in approaching people. Try to tell them try to make your profile how good you are, and then try to approach people. And wherever you go, you need to have some kind of background, right? So try to clear English. The English is important. Try TOEFL or IELTS. Or if you want, it's not only English. If you're interested in different languages, for example, German, uh, there are several institutes, several online apps that you can help you to learn different languages. Okay, so just do in the App Store or the Play Store that can help you different free apps that you can clear German very easily. Also the Spanish and French. The reason why is like they have lots of funding, but most people they go, they suffer with the language. They don't even. The reason is like these people they don't speak English. They consider English as their second language. And they even communicate with English. So if you get these languages done, it will be easy for you to communicate with these people very efficiently, and then you get into their culture, and then you learn a lot from them based on their understanding. So remember, most of the scientists they are from like Europe, and we also have people in India, but in the recent the documented scientists are from Europe, Russia, USA. So learning a language is not a bad thing to do. And Australia, you can still find if there is an English speaking country. Anywhere you can go, it's easy to get a PhD place, but the only thing is you need to get a funding. So funding is important. So you will end up with if you apply for UK, you will get numerous offer letters for PhD, but you need to find a funding for finding. And that's the challenge. And if you go to Europe, it's like a kind of two different challenges. So one is like they differentiate you between the European resident and they qualify you as a non-EU resident, which means you have to end up paying like more than 10,000 euros in addition to what you are uh, paying as a paying when the non UE student pays. Okay, and then so how to choose a place for work for PhD? Okay, so now you have like decided to decided to do a PhD push PhD, but where to go? Like in the national level or the international level, the first thing is like everything is about yourself, how you are happy, and are you enjoying learning things? Because PhD is a long way learning. It's like not like you do it for like 1 month or 2 months or 1 semester, 2 semester. It's your life. You're spending your life here. Okay, so decide accordingly. So what makes you happy and what makes you enjoyment, and decide your topic of research. If some people they give like a choice to choose your research. Okay, so how to choose your research? For example, people if you're still working on like a kind of a saber process, which is like a discovered over 100 years back. And if you're still interested in learning something new about that, you can still work on that, but people have discovered many things about it. But if you're still learning about COVID, it's still good. Yeah. So people are like, they're competing to find a drug for COVID. And if you are still like trying to find out the solar cell, it's still fine. But there are like solar cell research has been there for like more than 20 years now, but not with the desired efficiency. So you have to compete with the people to get the desired efficiency. And also like materials for electronics. There are several materials proposed, but nothing has been made available by the people in the industry. So academic is a kind of a dreamland. So you have to be very choosy in choosing your research topic. Choose the advanced topic. Choose something that no one has addressed it. Choose something that no one knows about it. Choose something that you are interested in learning about it. It can be biochemistry, it can be biology, it can be physics, anything, but try to be wise enough, try to be new, try to be advanced. Okay. And when you go for the group, okay, so many people, I mean, as a PhD student, you can decide your topic, but you need a supervisor. You need some help to do your research. For example, what is a research? Research methodology is a different one. There's even a semester allocated to people, allocated in that to learn about research methodology. It's nothing but you ask questions for everything. So why this is why, what, where, and when. So ask all the WH questions about a topic you have, and that's how the research forms in. So it's not like a standard way of publishing. You take a molecule, characterize whatever the techniques you have in your lab, and then publish a paper. That's not a research. That's a study. Okay. If you want to study, it's okay. You can do study anywhere. But if you want to do a research, it have to come from your mind. You have to involve your dedicated time on it. Okay. So try to have so much time available without focusing on any other things, but just on the PhD. Okay. And if you go to the lab, so when you choose a professor or the supervisor, look at his background. Okay, so not all the professors are good. This means like professors may be personally good, but you have to be like end up in a place where they are productive in research, working on some advanced things. Look at the publication history and also the funding history. Okay, so where they get funding from. If it is like they get like 10 projects every year or every 5 years, that's fine. If they get like a one project in 10 years, okay, let's avoid them. So it comes with experience. Always get help from your masters teachers. Okay, so always get help from teachers. Then always get help from your seniors or get from your help from your friends. Don't decide independently. This is the time that you need to discuss your problems with the people around. Okay, for the PhD, university reputation is not a big bother. For example, you work with your supervisor and you publish your result, and it doesn't matter wherever you do it. You can do it from India, you can do it from your native place, or you can do it from a local college, you can do it from a university or from international thing. But what matters is how quality your research is, yeah? How quality your publication is. So that has to be, I mean, comes from your hard work and your subject knowledge and your new thinking, etc. So this is how you choose a topic for your PhD, a group to work on. This applies also for the postdoc. So what's a postdoc mean? Yeah. So postdoc, like people try to get independent training. Yeah? So before you, I mean, doing a independent research is something different. It's very tough. Okay. So you need to get a guidance until the end of your career. So you people collaborate most of the time. So collaborative research helps you to understand many things. For example, if you do your kind of experimental thing, you can get help from the theoretical people to understand what's going on at the atomic level. You need to understand the mechanism. You need to understand the electron transfer process. You need to understand how the orbitals interact or how the orbitals orient. So there are many things. So it needs like a kind of a collaborative way. So you need a kind of training after PhD how to survive all these things, all these politics, all this like kind of collaboration, how to interact with the people, how to talk to the different people. For example, if you are a chemist, you need to talk about your research to the physicist. You have to talk about your research to the biologist so they can understand. Okay, so you have to be like a kind of expert in everything. It's not expert. You just have to be expert in a communicative skill and try to understand what their knowledge is, and that's what I call it as a soft skill. Okay. And postdoc can be like a national level or the international level. Even now these days, Indian government is spending lots of money to give you fellowship for to do a postdoc even at the national level or at the international level. Okay. The problem with the funding with the Indian government is like you can work for 2 years in abroad and then you have to come back to India to work for some universities here. So there are some constraints on the funding that we get from international level from Indian government. But if you go for like approach the professors independently, they always have funding for postdoc because they are the workhorse for the lab. Okay, so as a postdoc, you will carry your independent research, but you'll get some guidance from your supervisor. At the same time, you will have a capability to supervise PhD students and master students, especially in Europe and America, and also in India. Okay. And there are like prestigious fellowships available. What are prestigious fellowships? They're like Humboldt fellowships in Germany and like Marie Curie fellowships in Europe, and also like in USA there are several fellowships available. And even like people here, they once you get these fellowships, you can climb it over like all over your lifetime, saying that you are this fellow. Okay. And then this is also the time, the postdoc period is the time that you can enhance your publication record and tune up your thinking under guidance and find jobs and keep moving. So do not stay long, which means like any postdoc after 2 years is useless. Do 2 years of postdoc, try to find a job, either academic or industry, keep moving. Okay. So I think this is the kind of academic level setting. You start with a BSc, MSc, PhD, postdoc. Okay. What happens after postdoc? You can go in an academic job or in an industry job. So industry job you can take at any time. Even after BSc you can take, after MSc take, after PhD you can take. I'll tell you why you need a kind of exposure to the higher studies in the next slides. So let's go for the industry kind of settings. Okay, so why to prefer industry? Okay, so I mean, there's a general belief that people who ever publish in their PhD or the postdoc or like thing, they do extensive research on the topic that comes in future. For example, I did my PhD in quantum computing in 2010. Okay, only now the quantum computers have been recognized. Okay, the IBM and the Google are trying to set up quantum computers and materials for quantum computers. I use carbon materials, and there are like more than millions of material now available to enhance quantum computing. So we work for future in academics. So we never work for current scenario. Okay, only certain labs which is funded by industry, they work for the current scenario. But in academics, it's mostly advanced. Okay, so we choose from academic publication to get onto the precursors that can go into our chamber. So if you look at if you look at the studies that has been done like 20-30 years back, and we take chemicals from that paper to the current research. Okay. So this is what industry offers. Do a current time scenario. Do something that you can recognize immediately. For example, if you do an experiment today and the next week you will realize whether if this experiment will work or not. Okay. And this will develop your marketing mind. For example, how you can earn money, yeah, how you can get revenue for your company. That's how you develop business, and that's how the strategies. Okay, so there are several strategies that even we don't understand, that you have to come here to the industry and learn what people are thinking about, you know, how to develop a business, how to be very strategic, how to modify your thinking so that the business can be enhanced. Okay. And in principle, it's you patent the ideas here rather than publishing. So which means publishing is kind of a free thing. It's freely available to anyone. Patent, you invent something and then you kind of protect it, and whoever wants to use it, they have to pay money for you. That's how you fund people for their salaries. Okay. So that's preferred. What are the job opportunities? Okay, so now, we have like a kind of several job sites available. So I took Indeed.com, which is kind of a one top job site, and checked for the opportunities for the chemist. Okay, so what I ended up here is shown here. So trainee chemist, chemistry subject expert, junior chemist, QC chemist, so and faculty of chemist. So we have like chemistry is multidisciplinary, right? So nobody is jobless after finishing a chemistry degree. So chemistry is kind of ever blooming field. So you never end up kind of a situation where you feel regret for studying chemistry. Chemistry is always colorful, always always gives you plenty of opportunities. Okay, but if you look at the salary here, yeah, I mean, I never explicitly searched for the salary, but it listed here. Okay, it's like 1 lakh to 1.25 lakh per year. So 1.25 lakh to 1.7 lakh per year. So it's like a kind of a job that anyone can do. Okay, so it's not like a BSc people or MSc people. They pay you less if you go at the early stage. This is a kind of a problem with the kind when you have like a core level subject and then you try to do some kind of industry experience, you won't get paid too much. So do we really need to go there? I would say no. If you have your BSc and if you have a chance to go for MSc, go for MSc. Okay. And if you go for MSc, try to clear CSC or GATE examination. Even if you don't clear, try to find a job that matches your background, which has an opportunity to grow you further. Okay. For example, they should give you a opportunity for studying or opportunity for improve your career and so on. Just don't go for the small jobs. Always aim high. That's kind of one advice that I always have for you. The reason why I say here is like when it comes to industry and kind of a chemist, and right now you know that we are competing with the people who are doing like a computer science. Okay, this is the main difference. So before 20 years, I mean, IT was just developing. Now there are several IT people, and we have to. I mean, now it's easy for us to compete with IT people. For example, not only if you go for like BSc, MSc, but you have to be really at a high level. Okay, this is a kind of typical salary level that most people get end up if you go after BSc, MSc, and after PhD. This is based on like a kind of cost to the company. They say like, I mean, if it is like 50K, they say that you will what you get in your hand is like 30K, and say that the 20K is for your head charges, like for your PF and so on. So it's cost to the company, and it's developed based on analyzing several job roles inside. I mean, it's not my matter to put the numbers here, but I just wanted to be practical and say what you really qualify after your MSc, or after your PhD. Okay, I mean, if you're qualified a chemist after MSc, like you have like if you qualified to be a MNC scientist as a MNC, you will end up like 2 to 8 lakhs per year. But if you end up the same position after PhD, you will get significant boost. And then it gives you like a ladder of opportunities to move higher in the hierarchy. Okay, so what's a hierarchy means? Like if you go for like industry, there are like several kind of hierarchy. So it starts with the production, which is like a bulk level, and quality check, and then R&D and kind of management. Okay, so the higher the exposure and higher the studies, it will help you to get either in R&D and kind of management. Okay, QC is fine. It's like kind of a quality check is a routine job, but R&D is where you can expand your knowledge and so on. Expand your knowledge, create your ideas, and make a new product, and then you can also try to become a manager at a later stages of your life. So this is the hierarchy. So when you start looking for industry, I mean, you can go at any time, but if you really want to go high level at later stages of your career, try to learn something at every day. Try to move on towards your goal. Try to get your PhD. Try to get your master's. Try to get any exam clear. Okay, unless which you won't get like a good salary for a core level field. Okay, I mean, even these days the IT skills has become like a kind of challenging to maintain the jobs and also get like a good salary level. But it's for the chemistry, it's like a kind of evergreen job. So if you can become a subject matter expert in after 10 years, but it never happens in IT, and your job is very secure if you are like a very good scientist here, which is not possible in IT. So I mean, it's also possible that the chems people or the core people can also go to the kind of IT skills, which I'm coming to in the later part of the slide. But what you do when you come for like pharma and materials, okay? So the good thing, what you do here it's the same, okay? So you do experiments. What experiments? Either you synthesize compounds, or you deposit thin films, or you characterize devices. So anything, it depends on type of industry you go, okay? So, but the main idea is here is like you develop an idea in your mind and then try to design experiment based on that idea to validate that idea and then convert that to a process. What's a process? A process is a kind of routine method that helps you to deposit uniformly. That is a repeated. I mean, the experiments can be repeated anytime with the given conditions. Okay, that's we call it as a process, and that process has to develop to a product. So from idea to product is the main key here. So you can develop idea, but how do you make that into a product, and how do you market that product, and how people like, how do you make the people to like it, or how you make them to understand your quality of your product or how it can be useful. That's how these industries are trying to do. Okay, for example, in the previous talk we discussed about like the fertilizers, how he showed how it helps really to grow the plants, right? So it's not only the plants, it's like it goes for many things here. Okay, so it's how to define idea to product and market them. So it's also like an international job opportunities. It's not only national level, but international level you can get it. But getting an international job level straight away after a MSc is like a kind of it's not a straightforward process. Okay, because I mean, if you work for, I mean, it has been, it's possible. Everything is possible, but it's challenging thing. Okay, you have to work for it, and it's better you get some experience here at a local place and then try for international job opportunities. And it can be like either pharma or materials or the computational, which means like a drug design or docking and so on. And for permanent jobs in abroad, you really need to have a kind of master's degree at least at the US level or the international level master's or kind of a PhD. That always helps you. And if you really realize during your PhD that you are going for industry, don't spend too much time. Try to finish your PhD, and you don't even need to have a postdoc. Okay, you can straight away go to industry, because postdoc is not considered as experience when you move to industry. So it's try to be like as quick as PhD and try to get something onto your idea. Uh, and get that onto some companies, or you can start your own companies as well. So what happens with the IT platform? Okay, so I mean, I said like people in the code background can also go to the IT field. So what are the job opportunities? So I mentioned on the first part of my talk that you can also be like learn some Python coding. So the Python is everywhere. It can help you to model some kind of databases, query databases. The reason why I say databases is the following. It's a kind of a main subject, which is data warehousing and data science and artificial intelligence and machine learning. These are like anyone can learn. It's not only the computer scientist has to learn. Okay, so if you have like a +2 maths, you can still excel in the courses. Like the cloud era, Google is sponsoring lots of free courses these days. Okay, try to get certifications for this statistics cloud. Cloud is a kind of blooming field. Okay, so you can get a job here. You just need a kind of certification. It's not very difficult. Okay, you spend it's not difficult than CSA or GATE exam, so it's very easy. You study statistics, cloud, data. QC is like a quality check for the softwares. Okay, you do the same thing like in the people develop some kind of software, and then you are just checking that, and there's a kind of automatic and manual thing here. You can still check it. And the main important thing is the project management. There are several types of project management: agile and waterfall, and there are several processes. You can still get certificates called PMP courses, and then you can be like a project manager in top level industries. But all these are like a computer based works, and there are also lots of opportunities for, I mean, the reason why I say data warehousing is like it's like a kind of a chemoinformatics and bioinformatics, like the question raised in the previous talk. So whenever you have like a lots of data, you publish, there are more than like 100 and thousands of publications released every year. So you need to come into the kind of electronic format where people can query about it. Okay, so that's called query language. That's where like a big data and then SQL, Hive, and many things comes in. And you can also, like, a data science is nothing but you have a kind of a business platform, and then you try to analyze the data of previous sales on the previous years, on the previous month, and try to extrapolate that to the future. Okay, so what people likes and what people do not like, where to improve, and you provide that in the form of a graphical visualization. And that's how the data science is useful. So that's why we need the statistics to analyze all this background. So the cloud and data are like kind of information stored on the cloud. Cloud is a kind of a big device. It's not an independent device. It's just like a shared storage place. Apart from this data and also the cloud and also the statistics thing, what we have is like a kind of informatics, medical coding or transcription. This anyone can learn. So what this means is like people in USA, it's like outsourced medical coding, like for the different pharmaceuticals or different drugs, vaccines, they have a code and you can assign a code, and there's a kind of certification code. And apart from IT, you can also go for like a patent agents or a kind of a, where you can learn more about like how to protect your intellectual property and so on, which I'm not discussing here. And the final thing is like you can be an entrepreneur. So what's entrepreneur? You can develop your own business. Okay, so what's your own business? So you realize that something is important. Something came out of your master's project. For example, a new chemical or a new drug for COVID. Then you wanted to commercialize it. Yeah. So to commercialize it, you can start your own company, because I'm just giving you as an example. Okay, so most people at these days, if they form a vaccine for COVID, they are not planning to market it. They're just giving it, planning to give it for public. But this is just a simple idea I'm telling you about it. Okay, so you have a drug for COVID, and then you wanted to make money out of it. Then you have to protect it in the terms of a patent, and then you make a company to produce it in a bigger scale, and then you develop a kind of marketing strategy. Okay, so this is like that's what I say, that you need to be like have a multidisciplinary knowledge. So you need to form an entity. An entity means a company. So you need to form a company. How to maintain a finance for the company? How do you fund for that company? And how do you maintain the people? How to interview people? How to bring them on board? So this is not a simple task. So at the MSc level, this is not a recommended one. But it's still recommended if you are capable and if you have energy to work on it. But the main challenge will always be the significant amount of funding. Yeah. So if you have good at funding, it's more good. So it's anything is possible in the world. So if you say that, can I go up to that level? It really depends on what you feel about yourself. If I say that in terms of a Tirukkural, so it all depends on your mind, how you can go. Okay, you can be an entrepreneur, you can be a international PhD, you can be a professor at a USA, or you can be a project manager in any well-reputed MNC. It all depends on your mindset and your ambition. So with this, I try to finish my talk. Thank you. I will be able to address my talks. So I think with the basic overview, I have addressed like a kind of a basic questions that you might have specifically, what to do after your MSc, or what to do in a PhD, or what to do in a postdoc, or kind of what to do in a kind of industry level. So, this is like a basic thing. I'm always available in LinkedIn or WhatsApp, like the previous number, what I showed. You can always contact me. I'll be happy to help you. If you have any questions, I can address now.
Thank you, Muthukumar. It's been a very informative session. We enjoyed just now. Thanks a lot. And now I invite, before going for a few questions, I invite Mr. Gerald Anthony to deliver vote of thanks for this session. Mr. Gerald Anthony, are you there? Gerald sir, are you there? Gerald sir, are you there? I'm not able to see your, Gerald sir, I'm not able to see your name. Just a minute. Yes, yes sir, yes I have seen now. Yes, now you can, yeah, you're unmuted.
Yeah, ma'am, thank you. Shall I start?
Yes,
Hello?
yes.
Yeah,
Yes,
Honorable
please,
Chief
go ahead.
Guest, okay. Honorable Chief Guest Dr. Kaliappan Muthukumar, Scientist, Applied Material Science, San Francisco, USA. Present dignitaries, Principal Reverend Father Mariadas S.J., Conveners, Dr. Jayavansi Ruben, HOD Chemistry, Dr. Baby Marietra, Dean of Science and UGC Affairs, and Dr. Anto Arekaraj, Coordinator, PG Chemistry. Another notable day in the history of our chemistry department, St. College, Palayam Gotai. I thank our guest speaker, Dr. Kaliappan Muthukumar, for his presence and presentation. His talk make me to think about the poem of Dr. Robert Frost, The Road Not Taken, in which the author chosen the path without any guidance through intuition, but here our students are well guided by the speaker to choose the path which suits for convenience for an innovative idea of interaction, which is question scenario. Thank you, one and all, for the successful completion of this session. Thank you.
Thank you, sir.
Thank you, Mr. Gerald Anthony. Now we will straight away go to question session. Please, audience, if you have any questions, please act quickly so that we can move on to session 3 in Google Meet. Dr. Muthukumar is waiting for you to respond to your queries. Students, participants, I have some announcements. Just before receiving some questions, I want to announce you something. We are going to start session 3 in Google Meet. The link, the meeting ID, and the password is given in the chat box. So straight away, you can, after raising your question to Dr. Muthukumar, you can straight away go and enter into Google Meet by using the link given in the chat box. You have meeting ID and you have a password there. And Dr. Nalasivam from Pfizer Chemicals, Pfizer Healthcare Private Limited, Chennai is waiting for us there. So we are going to have session 3 there, and there I will post my feedback link, and then you can fill up the feedback link from there. Okay. So straight away, you just enter into Google Meet while we receive some questions for Dr. Muthukumar here in Zoom. Please don't ask for feedback form at the beginning of the session. Let it go. I know how when to post the feedback form. So I will definitely post the feedback form. Please listen to the talk. Please make use of the expertise that we have with our industry experts. That's the main thing. Try to interact with the experts and get something useful for your career from them. Any questions? Okay, I will start, Dr. Muthukumar, with a question. A girl student raised a question like, what is the scope for women chemists in industry?
I mean, always there is a chance. I mean, after you finish your MSc, there is not really a difference between a girl or a boy. You know, even my manager is a lady for a while before. So it's like how you project yourself. There's no gender difference if you go up in the field.
Okay. Then there was one more question. If at all I want to start a chemical industry, what is the thing I have to look for? In what way I can train myself? That's a question from one of the registrant.
Okay. I mean, if you want to start a company, the first thing is like you start a company, try to get so much money as possible, and before that, have an idea. I mean, what are you going to? What's your going? What's the product of your company? Yeah. So is this useful for your people, or how we are going to market it? So try to have a kind of a rough idea, and once you know that it's going to be successful, form a company, try to hire people who can help you with the process of getting into the product. And once you get into the product, you have to find people to market it and get succeeded. Okay. So the first thing and basic thing is to get an idea, the strategy, and also what product you are going to develop.
Okay, and I will unmute Arun Kumar. Mr. Arun Kumar is asking some question. Um, Before that, Jeba Godwin is asking something. Let us listen to him. Mrs. Jeba Godwin, Ms. Jeba Godwin, you can raise your question now. You are unmuted. Okay, let's move to Arun Kumar. Arun Kumar, are you there? Okay. I think Dr. Ginil Moon is trying to ask something. Dr. Ginil Moon?
Okay, thank you. Thank you for the permission. Sir, thank you for your talk. Highly informative for the students especially. My question is, you initially when you start up, you told about molecular docking, molecular modeling. Can you mention a few of the advanced softwares which we can use? Not just you people, you are industrialists, you will be prone to all sorts of high-end applications. But for academicians like us, maybe less cost softwares.
I would say that academics have more advantage than industry people in terms of software. The reason is you get everything free and we pay everything. We pay
Yes,
for
okay.
everything.
Can you mention few of those free softwares, advanced ones, which is available now?
Yeah, you can, for the molecular modeling, it depends on what you are going to model, right? If you are going to model polymer or protein, for the protein, it's like a kind of GROMACS or the NAMD, non-adiabatic molecular dynamics. And also for the polymer, it's a LAMS. And if it is like a kind of a quantum chemical software, you can use like a Gaussian. Gaussian is a paid software, but there are like a free software like Worka.
Okay.
Yeah.
நான் சொல்லிடுறேன் announce பண்ணிடுறேன்.
And then if it's like a docking, it's like Autodock. That's the best gold thing.
Actually, I have tried Autodock very recently, but it has some compatibility issues, it seems. It is not getting installed properly. I have tried many options.
Yeah, it it's the open source comes with always the problem. It's better like we can address one-to-one later if there's software installation issues.
Okay. Thank you, sir. Thank you very much. Thank you, ma'am.
Okay, then is there any questions? Yeah, some students they have said, thank you, sir. Lots of different ideas I got, and you cleared it nicely. This is from Sandhya Swashini Kumari, and one more person has asked you a question.
Mary, ma'am.
Yes.
Few questions are available in the chat box. If you can.
That's what I'm trying to. Yeah, sir. Is there any private funding agencies available globally to start the fundamental research? Krishna Murthy Periyasamy is asking this question.
There is always people who are ready to fund for research, right? But the only thing is that you won't get freedom to publish your research. You can get money to do your research. You will be able to understand the chemistry, but what's the use of it? You can't publish or you can't patent. Everything has to be like given to the funding agents. So there are people available who can fund for the independent research. It's how you find them.
Okay. Another question is, how to improve our practical knowledge about chemistry? This is a question from a student.
Yeah. So practical knowledge is like two things. Yeah. The one is like you do experiments or you do like experiments in computers. Okay. So experiments in computers are relatively easy. Then you design the experiments in lab. Yeah. I mean, you won't be able to set up a lab in your home, or even you don't have freedom to do experiments in a laboratory without your supervisor's choice. So the best thing is read. Okay, read about different things, what the people did and how they. I mean, usually the publications will come with the data of how they performed their deposition or the synthetic loads. Okay, try to understand them, and that's the first starting point I would say. And if you want to do really practical things, you really have to have your own lab, and that comes at the later part of your career. The first thing to start is like read.
Okay. Thanks a lot, Dr. Muthukumar. There are many questions to be asked, and definitely I will direct our students and faculty members. If they have any queries, I will give your email ID and I will try to connect these people with you. Thanks a lot for your wonderful
Okay, thank
time.
you.
And please, we wish a safe stay there in USA. And we are now moving to session 3 in